Iceman sir. Yes, good afternoon to all. We all know that mathematics is a subject which makes a man methodical and systematic, prevents us from any chaos. Certain qualities that are nurtured by mathematics are power of reasoning, creativity, abstract or spatial thinking, critical thinking, problem solving ability, and even effective communication. It is evident that these attributes are consequences of practical analysis of matters around us, developed from counting, calculation, measurement, and systematic study of shapes and motions of physical objects. Practical in mathematics has been a spontaneous human activity from as far as back written record exists, and school is the place providing a structural platform for such since beginning of civilization. This pandemic has compelled us to witness this core activity of mathematics in a virtual platform today. In this scenario, I would like to take my privilege to welcome the esteemed chairman of the institution, Sri Sarat Chandra Misra, our respected principal sir, Dr. Kesab Chandra Satpathy, Revered principal of the sister concern schools of DAV, respected coordinator madam Indra Bhattacharya, all supervisors and my dear participants and all the viewers in this platform today. Now it is time to welcome our jury members. Dr. Prayag Prasad Misra, professor in mathematics in Silicon Institute of Technology, done his PhD on delay differential equation and has publication of more than 20 journals in national and international level. Dr. Kanan Kumar Patra, PGT Mathematics, KV3, Bhubaneswar, having 17 years of teaching experience. So I would like my dear friends in this platform, today you are going to enjoy whatever activity you are going to do. Now, I would like to request our Archana madam for further proceeding.
Without change, there is no innovation, there is no creativity. Those who initiate change have opportunity to manage change that is inevitable. I hear and I forget. I see and I remember. I do and I understand. Good afternoon to one and all present in this virtual platform. Every year, our school organizes annual project display to create an opportunity to our students to explore in various subjects. Our exhibition's target is to encourage innovation among young generation as they are the nation's future. Due to this pandemic, this year, Maths annual project display is being conducted through virtual mode to motivate our young minds to showcase the wisdom and creativity. Before getting started, let us know the rules of assessment process. Each group should have maximum number of 4 participants. Let me mention that here we have some solo participants also. Each group will be given 7 minutes for their presentation and each group will be awarded from 50 marks. This 50 marks is further divided into presentation, which carries 10 marks, mathematical concepts, 10 marks, model, chart, PPT carries 10 marks, innovative application, 10 marks, question and answer, 10 marks, which sum up to 50 marks. Without any delay, let us move to the first presentation of the day. To start with, the first project, that is access to competitive probability, which will be presented by Bhavya Bharadwaj and Ipsita Satpathy of 11E. My dear participants, you can present.
Thank you, ma'am.
Dear children, kindly switch on the video.
Ma'am, we want to know whether we are audible and visible or not.
Yes, you're audible. Please switch on your video.
Ma'am, the video is on.
No, my dear.
Ma'am, in another device.
Yes, you can continue.
Okay, ma'am. Okay. A very warm and safe afternoon to all the esteemed jury members, my respected teachers, and my dear fellow participants. We, Ipshita Satpathy and Bhavya Bharadwaj of Standard 11E, are here to present you our model titled Access to Competitive Probability. Probability. Probability theory is nothing but common sense reduced to calculation. The theory of probability is the only mathematical tool available to map the unknown and the uncontrollable. It is fortunate that this tool, while tricky, is extraordinarily powerful and convenient. The concept of probability is as important as it is misunderstood. It is vital to have an understanding the nature of the chance and variation in life in order to be well informed or efficient citizen. Bhabya, I remember that yesterday I came to your house and we decided to play a game throw a dart. Could you spell out the rules? Yes. So we have decided the rules to be if a paper I pick up has a number from 1 to 4, then I clearly lose the chance. And if I pick up 6 to 9, then I win the chance. And if I picked up a number which is 5, it indicates that I can try again, giving myself another chance. And the point to be noted here is that if a number 5 comes to my hand, then I'll be given second chance to throw a dart. As all of you can see here we have a dartboard. But here we have the numbers from 1 to 9, which we have written here in some of the cheats. Now, could you please pick up a cheat? So here are the cheats. Before opening up, let me say you what are your probabilities of winning, losing, and trying out again. So, for as we know here, the total outcome is 9, and the possible outcomes for winning is 4. That is 6, 7, 8, and 9. And the possible outcomes for losing is 1, 2, 3, and 4. Now, if you here the probability of winning and losing is 4 by 9. Let's go to the special case where if you pick out 5, then here in this chance, your probability is 1 by 9. But you get another chance where either you can win or you can lose. Here, again, the winning probability is 4 by 9 and losing probability is 4 by 9. Now, let me separate both of them. If you pick up a number 5 and you win, then your total probability would be 1 by 9 into 4 by 9, that is 4 by 36. Whereas if you lose, then similarly, it will be 1 by 9 into 4 by 9, that is 4 by 36. So here is an illustration of the calculation that we just told now. Now please disclose the paper. Okay, so I got a number 5. Now moving on, we know that in medical sciences also probability plays an important role. Medical science is all about probability. Let's take a case. Here we have done a project where we have a couple and this couple exactly wants 2 sons and 2 daughters. But will you tell me, Ikshita, how can the couple get 2 sons exactly? Yes, sure. As we know, in general sense, the childbirth, being a boy and being a girl, it is 1 by 2. This is all the magic of genes. But as you here, the boy and girl both are independent of each other, and in both the occurrence there is no common element, which proves that they are mutually exclusive events. Further moving that when we add both the probabilities, that is 1 by 2 plus 1 by 2, it comes out 1, which also defines that they are mutually exhaustive events. Now, using the formula NCR into success probability to the power n minus r into failure probability to the power r, we resolve it. That is 4C2 into 1 by 2 to the power 4 minus 2 into 1 by 2 to the power 4 minus 2. But this is all about the probabilities that has already been proven. Can you say that during a crisis, in the middle of a crisis in which we are right now, how probability is going to help us?
Yes, Ipshita, there is obviously one area in which this is extremely important, and it is in understanding risk and relative risk. Let me describe you what it is. When a person is at a verge, when a person has a chance of dying in some pandemic crisis like COVID-19, and the chance of dying has just doubled, then it is important that they must know, maybe because they have gone from one chance in a million to two chances in a million of dying. Sure, it has doubled, but it is in still trivial. But it is in still pretty trivial.
Now, I have a question for you. Suppose you're evaluating a patient, and due to prevalence and due to some symptoms of COVID prevalence in your community, this patient shows mild symptoms. You estimate that the person probability for COVID-19 is 1 in 10, that is 10%. The person is then tested and the test result is negative. So, does this person need to be quarantined?
The probability of illness is shown in the table as we are showing you in the screen now. The probability of 10%, as can be seen given in the test characteristics of 70% sensitivity and 100% of specificity. In the probability of having COVID-19, the contingency table now shows you that a person will have a probability of getting 1 in 31 of having a COVID-19 positive test.
So from here, we get to learn that probability is involved in our day-to-day life. Everything we do, before we want the win and loss, we calculate what do we get. Before doing something, we always think what will be the benefit and what are the losses. Here comes the role of probability. With this, we sign up. Thank you so much.
Sir, and if any queries are there of our fellow participants and our respected jury members, then please, we are obliged to answer.
Okay. Hello, Bhavya and Ipsita. Am I audible to you?
Yes, sir.
Yes.
Okay. So thank you so much for presenting a good presentation on probability. I just want to know from you how you will differentiate mutual exclusive events and independent event. Mathematically, are they same or they are different?
Sir, mutually exclusive events are something which is independent of each other. They are not dependent upon each other, and both of the events or the occurrence of the events, they don't have any common intersection.
Okay. What about independent events?
So independent events can be called as the individual events which are in a set.
Can you give a small example so that I can differentiate them easily?
So independence events is that, so like in a six-sided die, we can never get 5 and 2 at the same time. But while tossing a coin, we can only get at the same time. While tossing a coin, we can also get head or tails. We can never get the both. So it may be an example of an independent event.
Okay. Suppose in this competition, there are 9 participants, 9 groups, including you. Can you tell me, and we are going to offer only one prize, best presentation award. What is the probability that you will be getting the prize with a tie? Means another group will win your score will be also matching with them.
Sir, I think it will be 2C9.
Are you calculating combinations?
Sorry, sir, we just messed it up. Can we calculate now?
Okay, you do it afterwards and let us know. Okay.
Okay.
Anyway, thank you. Thank you so much.
Thank you, sir.
Thank you, children, for your presentation. Moving to the next project, that is Math plus Magic is equal to Origami, which will be presented by Sankalp Tatwadarshi, Tanmay Mahapatra, Divyan Sukar, Prabhanjan Sahu from 10A. Dear children, please on your video. Dear
Ma'am, I hope
children,
I'm
kindly on your
audible as well
video.
as visible.
Yes, yes.
Thank you. A very good afternoon to one and all present over here. On behalf of my team, I welcome you all to our project display. Today our topic is flapping birds and space telescopes, which may seem to have no relation at all. But I hope at the end of these 5 minutes, you'll somehow be able to get the big picture. Without any further ado, let's start. Most people think they know what origami is. It's this, flapping birds, toys, cootie catchers, and that sort of thing. But that is what origami used to be. Today, it has become something else. It's become an art form, a form of sculpture. The common theme that makes origami what it is its folding or how we create the form. Before we go any further ahead, we like to say, Sankalp, wait a second. We have been doing origami since our childhood. Can you be precise and tell where exactly does the math lie in all of this? Stay connected. We are close. The most powerful tools in origami have been related or associated with how to get parts of the structure of the subject. And I can put it in this very simple equation. You can take an idea, combine it with a square sheet of paper, and you get the origami model. Simple, isn't it? It's not. So how do we do it? We break it down into a few smaller steps. So let me stretch out that equation for all of you. First, I have an idea. Then I abstract it. What is the most abstract form? It's a stick figure. Now from that stick figure, I somehow have to get a folded shape that has a part for every bit of the subject, like a flap for every leg. From that folded shape, called as the base model, I can add in details, like I can make the legs narrower, I can fold them, and turn it into a finished origami model. Take a look at it again. The first step, it's easy. We can draw a stick figure, all of us can. Can't we? The last step is also not that hard. But that middle step, going from an absolute abstract description to something that's a folded shape, that's hard. And that is where the mathematical ideas can get us over the hump. The figure that we had seen had a bunch of flaps. Today, we are going to learn how to make one flap so that all of you can go home and unfold something. So, first of all, I start with taking a square sheet of paper like this. The steps are on your screen and you can look at me in the video so that it will be easy. First, fold it in half diagonal. Fold it again in half, and that's all you require. That, my friends, is called a flap. What amount of paper went into the flap? You unfold it again and you can see the top left corner of the paper went into the flap. If I want to use less amount of paper for making the flap, I can make it skinnier. Like this was our original flap. I fold it in half again. It becomes skinnier. If I make it skinny enough, like when I reach the limit, I'll see that it requires exactly a quarter of a circle to make a flap. This was one of the methods. Another method involves where you shift the center of the flap to the center of the edge, like in the top one shown. We will see that it will require exactly semicircle to make the flap. And if I shift it way down to the center of the page, it would require a complete circle to make the flap. What do we conclude from all of this? We can say that we can make a flap by using a part or a complete circular region. Now we scale things up. What do I do if I have to make something with a bunch of flaps? I need. We can conclude that we can make arbitrarily complicated shapes simply by using the concept of circle packing. I can rely on the vast history of mathematicians and use their solutions to solve the problems created by this concept of circle packing and hence create my crease patterns for the origami design. If we remember what I had said, origami is not what it used to be. It has, over the course of time, it has modernized itself as well as its real life applications. What are its applications? Take a look at that. Tanmay, please.
Thank you, Sankalp, for the beautiful elaboration on the working principles and the math behind origami. To put it in other words, origami is a beautiful dance of congruent shapes, gives rise to compact yet robust and reliable structures which aid in solving real life problems. Where you may ask, let us dive straight in. Fitting large solar panels in rockets. One must wonder sometimes that how exactly are the massive solar panels upon space satellites and telescopes accommodated in rather conservatively sized rockets and launch modules. The answer lies in this art of folding, that is origami. The concept of packing circles with crease patterns described by my teammate Sankalp comes into play here. As you see in the animated GIF, the circular fold pattern gives rise to a reliable unfolding pattern of a circle. This property is exploited by replacing the folds with metal hinges and the photovoltaic cells themselves as the sheets attached to the hinges. And voila, you just fit a large solar panel upon a small rocket. Heart stents. Enough time spent in space, let's come back down to earth for a second. You must have heard of a surgical procedure called an angioplasty, wherein an inflatable balloon is inserted by the patient's thigh to relieve blockages in the arteries. The problem which arises here is that the blood vessel in the thigh is a lot thinner than a lot of the major arteries, causing a problem in the deployment of a balloon solution. Origami comes to the rescue here as well. The ingenious folding pattern you see on your screen in a few moments is the very mechanism used in balloons and stents to be able to make its shape thin enough for deployment and yet inflate to be able to practically relieve a blockage in a large artery. The conclusion. These rather serious and scientific applications breathe in a lot of seriousness into just an art form. As weird and as surprising as it may sound, origami may someday save a life. Well, guess what? It already is. On behalf of our group, I would like to thank all of you for your patience and attention. I hope you have it. Thank you.
Okay, thank you so much. Actually, I didn't understand properly the origami we are going to use while implanting a stent. What is the role of mathematics there? Can you please explain?
So the role of mathematics is exactly while designing the model. The whole thing that you see is a final shape. But
I just wanted to know the exact mathematics behind the design of this model. Do you have any idea?
So the properties of symmetry and congruency are exploited here for making an object compact enough at a certain point, whereas it still has the property of being able to change its shape smoothly enough. So it basically allows its application a lot of industrial design concepts.
That becomes a very generalized answer. Can you explain how congruency plays the role?
So when we are folding some,
that would be easy.
Yeah.
So if we carefully take a look at one of these pages, it would be take a look at this. So in this figure that you can see along this central diagonal part that is going from the bottom left to the top right, each of the figures that are adjacent are symmetric. Like here, the figure I'm pointing to, this triangle is congruent to this one. This shape, that's a trapezium, is congruent to this part. And how is it congruent? We can prove it through the symmetry that we are drawing. This is the basic principle that is applying to each and every origami figure that we do. May it be heart stents, may it be the circular folding shape, each of them.
Okay. Do you have any idea about these fractals and all? Fractals.
Pardon?
Fractals.
Fractals. Sorry, sir.
No.
No, sir.
Okay. Okay. Thank you.
Thanks.
Thank you, dear participants. Moving to the next project, that is a triangular gamer. The presenters are Suvam Swapnil Das, Tejaswini Sahu, Srishti Sivangi, and Ketav Mishra of 10E. My dear, be ready to present yourself on your video. Kindly on your video.
Mom, we have switched it on.
We're starting.
Yes, you can proceed.
Starting from the craze of snake mobile games in 1990s to the trending of Among Us, gaming science has reached heights of development in a mere decade. But what gamers do not realize is that they have been dealing with maths all along. A very healthy afternoon to everyone. Today, we are going to talk about video game programming and how is it related with trigonometry. To answer that question, I, Ketav of Tenny, present with my friends Shivam, Shrishti, and Tejaswini, are over here to take you to a place where trigonometry and computer science intersect. Video games use trigonometry in various fields, including collisions, effective gravity, trajectory of projectiles. Many games are highly competitive, making its accuracy very important.
So, am I clearly audible?
Yes, you can continue.
Okay, ma'am. So, are you also a lunatic game lover? If so, then you must have played the popular game Clash of Clans, where the players shoot out their enemies in a circular range. The distance of the enemies from the player is equal. If the player shoots at an angle theta and the distance of the enemies is b, then the computer calculates the exact location where the arrow falls by putting tan theta function. This game needs no introduction. Pokemon Go, made by Niantic, gained popularity among the teens as soon as it was developed. Using the technology of augmented reality, the player has to flip his mobile in order to catch the Pokemon which doesn't exist in real life. The computer calculates the spot where the Pokeball falls when the player flips his mobile at an angle theta by the help of cos theta function.
It is not audible. Continue. Ketav Mishra.
Hello? Am I audible?
Yes, your
Sorry.
video is off. Kindly switch on your video. Yes, my dear.
Sorry for the. Have you seen Star Wars? If yes, you will notice a baby Yoda passing secret messages to his companions through holograms. In the near future, we are expecting the use of holograms in video games. These are not possible without the use of trigonometry. For a better understanding, we prepared a homemade hologram. As you can see through Tejaswini's camera, where in a gaming prospect, a lady is holding a gun. Suppose the lady is a CPU player and the gun is placed at an angle theta parallel to the ground. The theta changes every instant. If the player shoots the gun at an angle theta and distance b, then the computer has to calculate the exact position where the shot is targeted by tan theta function. As you can see, the hologram provides gaming a more realistic and in-depth experience.
Now let us look at the syntax which game developers use. The use of sin x and cos x function is yet another instance how important trigonometry is in the world of games. Not only video games provide us enjoyment, in the future, they will definitely have an extensive use in educational field. Educational holography games will provide a better learning approach which is impractical without trigonometry. Trigonometry not only applies but also has a definite role in making our future more exciting. Thank you so much. We are open up for any queries or questions from your side.
Hello, Subham and group. Here is a question. Beside your trigonometry, is there any mathematical concept which is being used in making video games and computer games?
Thank you very much, sir, for this question. Actually, if we consider every concept of mathematics is used, in the prospect we use, except trigonometry, we use the parabolic function. Parabolic function, why? Because when you will hit a car during a car crash, let me show a small example. During a car crash, you hit a car hit a car and it flies to a certain height. Then again, it has to come down. Their projectile motion plays a very important role. And if I see another that is coordinate geometry. Coordinate geometry I can use in underground and above the sky. If I take the clouds to be the clouds as the origin, the center of the clouds, above the cloud it will be the positive axis, and under the ground it will be the negative axis.
Okay, very good.
Thank you very much, sir.
Okay, just I have a small question to you. You tell me, for what value of theta, sine square theta plus cos square theta will be 1?
Sir, actually it is all values.
Thank you. So it can be even imaginary values?
Sir, imaginary values, yes, sir, definitely. Because when we square it, even imaginary, if it is minus, it becomes a plus. If it is root over, it becomes a natural number in that case.
Okay, so you told about coordinate geometry. Up to what dimension you can imagine?
Sir, this dimension can actually, during the 12th study, we go to the 3rd dimension, but we can have a 4th dimension also.
Okay. Okay, thank you.
Thank you very much, sir.
Thank you so much, sir.
Thank you, dear children, for your presentation. Moving on to the next project, that is Perplexing Paradoxes, which will be presented by Arman Payashat, Priyanshu Samantrai, Pulakit Biswal, Sanket S. Mahapatra of 10A. You can start your presentation. Arman, Priyanshu, Pulakit, Sanket. On your video, your voice is not audible, my dear. Kindly unmute. It is not audible.
Audible now?
Yes, yes.
Okay, thank you, ma'am.
Start. Yes, unmute. Your voice is not at all audible. Don't use your phone. Please don't use your phone. Yes.
Yes, ma'am.
Yes, good.
Okay, thank you.
Start, my dear.
Very pleasant afternoon to one and all present over here. Today, I, Arman Pratik Pasayat, and my teammates Priyanshu Samantrai, Pulakit Biswal, and Sanket Subhraluk Mahapatra are going to present our maths project, Perplexing Paradoxes. So here, we have devised an innovative method of calculating the digital sum of a given date and then choosing 4 numbers from the given numbers from 1 to 9 as our paradoxes. So first, let's take Gandhi Jayanti. 2nd October 1869. 2 plus 10 plus 69, which will give us 81. 8 plus 1 will give us 9. I would request Sanket Mahapatra to open the project number 9.
It's birthday paradox.
Okay, so now I'm going to click on the number 9.
So let us start from a very famous and interesting paradox known as the birthday paradox. Imagine a group of people. How big do you think the group would have to be before there is a more than 50% chance that two people in the group have the same birthday? Just think about it for a while. The answer might seem surprisingly low. A group of 23 people, there is a 50.73% chance that two people in the group have the same birthday. You might wonder that in an ordinary year of 365 days, how is it possible that only 23 people are required to have a 50% chance? Let us understand this. Since calculating the different possible combinations of a shared birthday will be very challenging, so let us go the other way. Let us calculate the probability that no two people in the group have the same birthday. One day a year will be the first person's birthday. This leaves 364 possible birth dates for the second person. So the probability that the first two people have different birth dates will be 365 by 365 into 364 by 365. Similarly, there will be 363 possible birth dates for the third person. And if we proceed in the similar way, there will be 343 possible birth dates for the 23rd person. Hence, by using the concept of probability, the probability of no shared birthday will be 0.492703. Since the events of a shared birthday and no shared birthday are mutually exclusive events, so the probability of a shared birthday will be 1 minus 0.492703, which is 0.507297, which is approximately 50.73%. And hence the result. Unfortunately, our brains are notoriously bad at intuitively grasping non-linear functions. Once our brains accept that, the birthday paradox makes more sense. For the same reason, in a group of 70 people, there is a more than 99.9% chance two people have the same birthday.
Let's go back to dashboard now. Now, we will cover Republic Day, 26 January 1950. 26 plus 1 plus 50, which gives us 77. 7 plus 7 gives us 14, and 1 plus 4 gives us 5. I would request Sanket Mahapatra to open the number 5 in our project.
It's Grandy paradox.
Okay, so now I'm going to click on the number 5.
The Grandy series is a very interesting paradox which was named after the Italian mathematician Guido Grandi, who devised a very innovative way of solving it in the year 1703. It can be simply stated as sigma of minus 1 to the power n, where n varies from 0 to infinity. Or in layman's terms, we can say 1 minus 1 plus 1 minus 1, so on up to infinity. There are three possible answers to this. The first one is 0. If we group two ones together and assume that the number of ones is even, so the answer will be 0. But if the number of ones is assumed to be odd, one will be left out, and so the answer will be 1. But there is a way to get answer of divergent series 2, and that is known as the Cesaro sum. So the sum of this series is assumed to be the mean, that is 1 by 2. Now I would request Arman to proceed.
Let's go back to our dashboard. Since we've already covered 2 of national holidays, why miss out on the third one? Independence Day, 15th August 1947. 15 plus 8 plus 47, which will give us 70. 7 plus 0 will give us 7. I would request Sanket Mahapatra to open the number 7 in our project.
It's Thompson's lamp.
Thank you. So now I'm going to click on the number 7. Thomson's lamp is a very famous paradox which is based on the concept of infinites. It was devised by the British philosopher James Thomson in 1954, who used it to analyze the possibility of a super task. So in this paradox, we consider a lamp with a toggle switch. In this one, flicking the switch once will turn the lamp on, and flicking it again will turn it off. Starting a timer, a very patient person starts flicking the switch after 1 minute, then after half minute, then after 1/4 minute, and so on in a GP. So the sum of this infinite series will come 2 minutes. But now the main question arises that will the lamp be on or off after 2 minutes? So this question is directly related to the business, which my friend Priyanshu has already explained. So according to my friend Priyanshu, the Caesar sum comes first, but now it is problematic as it would be half on or half off, which is not possible. And so here Thomson reached and concluded that I take this to mean that there is no established when a super task is done. In simpler words, even though there is a sound reasoning behind the paradox, the result is logically unacceptable or self-contradictory. And that is why Thomson's lamp was added to a list of the paradoxes. Now let us go back to our dashboard. Sankit Mahapatra, would you like to share your date of birth with us?
Yeah, it's 21/12/2004.
Well, that's today. Isn't it a nice coincidence? Happy birthday, Sankit.
Thank you.
So would you like to open the number 1 for us?
Yeah, it's chocolate paradox.
Okay, so now I'm clicking on the number 1.
Chocolate paradox, or the infinite chocolate cake, as it is fondly known, can be considered as a special case of Banach-Tarski, which is highly counterintuitive. In this paradox, a chocolate is cut into pieces, and the pieces are so arranged such that the dimensions are retained, but one piece is still left out. As you can see in this graph, how the chocolate paradox is demonstrated. Well, let me say the trick, the secret behind. The secret of this paradox is when the diagonal cut is made into the chocolate and rearranged, an optical illusion is created that all the pieces are of same height, but that's not the case. The volume of the chocolate resulting out in the rearrangement is less than the original one by the volume of one extra piece due to irregularities in height. So let me demonstrate it in practically. As you can see here is a chocolate bar. Can you see the leveling? Here a line and here also. Let me arrange them in another way.
Yes.
Let's move this.
Try to complete
here
fast.
and here. It is a little messed up. As you can see the secondary height, how it is just changed about this much height. If you will take the area and measure the area of this one, both will be same. So as you can see here how it is demonstrated. Thank you.
Now, we've come to the end of our presentation. Thank you. Any questions from the judges will be highly appreciated.
Okay, thank you. Thank you so much, particularly for the chocolate paradox. Tomorrow is 22nd December. Any related to anybody from mathematics field?
Sir, it's the National Mathematics Day, Ramanujan's birthday.
Okay. So Srinivas Ramanujan also had some paradoxes. He had discovered few conjecture. Do you have any stock with you?
Yes, sir. Sir, he had proved that sum of all natural numbers is -1/12, which is very counterintuitive as it is a fraction and it is even negative also.
Good. And you know that prime number generation of Ramanujan? Pi of x minus pi of x by 2 is less than equal to 2. Okay, you can go through it. I have a question for you. Just listen the question. As you have initiated probability, suppose I have all my waistcoats. I'm wearing a waistcoat today. So all my waistcoats are blue in color, except one. Second statement is, all my waistcoats are red in color, except one. All my waistcoats are black in color, except one. Okay, these are the three statements I have for you people. So you have to tell me what is the probability that tomorrow I will be wearing black waistcoat. You have to calculate the probability of wearing a black waistcoat tomorrow. What is the chance? Any difficulty in understanding the question, you can ask me again.
Sir, each waistcoat will have the only one color, right?
No, I said all my waistcoats are black in color except one. All
Yes,
my
sir.
waistcoats are blue in color except one.
Yes,
All
sir.
my waistcoats are red in color except one. So I want you people to think about this question. Answer will be given to you, but you take some time and find out the answer. Then we will discuss offline. Okay?
Okay, sure, sir.
Okay.
Thank you, sir.
Okay, sir.
Thank you, dear children, for your presentation. It's again a reminder the time limit for each presentation is 7 minutes. Kindly stick to that, my dear children. Moving on to the next project, that is Principia Calculi, which will be presented by Sanket Das, Subhranshu S. Chowdhury, P. Stitapragya, Suvam Saswat Das of 10A. Dear children, please switch on your videos.
Good afternoon, everyone. I am Subhranshu with Sanket Das, P. Stitapragya, and Subham Saswat Das. We welcome you into a grand topic, Principia Calculi. From the term Principia, what can we understand? It means principle, and calculi stands from calculus. The term calculus, you must be wondering what it is. Calculus, the study of change. It interrogates you what is the instantaneous rate of change of something. Calculus is a broad area of mathematics dealing with such topics as instantaneous rate, change, area under the curve, sequence, and series. Calculus is of two types, integral calculus and differential calculus. Differential calculus based on the concept of real number, function, limits, and continuity. Here are a few examples of differential calculus upon your screen. Next, we have integral calculus. Studies the notion of an integral, its properties and methods of calculation. There are two types, definite and indefinite integral calculus. Few examples of integral calculus are here. Next, there is a big question. Why to learn calculus? What are its applications? Is it necessary for us? The answer is quite yes. It is very, very essential for us, and we are unaware of those stuffs. Calculus is essential for many areas of science, engineering, biotech researches, and chemical industries. Both make the heavy use of mathematical function to describe and predict physical phenomena that are subject to use of calculus. Now let's have a look upon the use of calculus in architecture field. Architecture use calculus to make bridges and domes. It uses integration in determining the amount of material needed to construct a curve of dome over a sports arena. In differential calculus, it is most important in figuring out how to minimize or maximize the aspect of windows. For example, in a building, to maximize the window size to create the derivatives by taking the maximum proportion. The architect uses integral calculus to find how much heat is lost by a body by taking a temperature scale. Let's have a look upon the further applications.
Now, let us see some applications of calculus in the field of electrical engineering. Calculus is used in circuit analysis. It is used to determine variation of change and also the instantaneous value of current, resistance, inductance, flux, etc. We also use integration to determine the exact length of power cable needed to connect two substations that are at a great distance from each other. Hence, in this case, calculus helps us to save our money and resources. It is also used in the designing and manufacturing of various electronic appliances, starting from the tiny smartphones to supercomputers in labs. Now let us see some applications of calculus in the field of rocket science or astrophysics. Astrophysicists and rocket science and planetary scientists use calculus to calculate the changes in temperature and gravitational pull of various celestial bodies, starting from moon to black holes. Engineers also use calculus to design space shuttles and rockets, like the one you'll just see go. Calculus is also used to obtain important information regarding the trajectory of a space shuttle, like ascent, descent, etc. Here you can see the trajectory of a sounding rocket launched by NASA. Calculus was used to design this trajectory in such a manner that maximum output will be obtained from this rocket.
Next comes the application in biology. In the field of microbiology, calculus is used to determine the rate of growth in a bacterial culture. It's also used in research work by varying the light, food, or the environment. Next comes the application in epidemiology. In the field of epidemiology, calculus plays a major role. It is used to determine the exact rate of growth in the number of affected individuals. In recent time of COVID-19 situation, you might have heard in news or by doctors saying about terms like first peak, first wave, second wave, etc. These all are determined with the help of calculus. Calculus tells us at which date the expected amount or expected number of individuals to be affected.
Yes, you want to present anything else?
Ma'am, actually, I think there is a technical glitch.
Yes, now it is audible. Sanket, please unmute. Sanket, Sanket, you are saying something. It is not at all audible.
No, I think he's not able to unmute himself.
Please unmute yourself.
Ma'am, I was not the co-host, so I couldn't.
Yes, now it is audible, dear.
Now, let's move towards the application 5, graphics design. You must be wondering, how is calculus used in graphics? A graphics artist uses calculus to determine how different 3D models will behave subjected to rapidly changing conditions. This can be used to create a realistic environment for movies or videos. For example, in your favorite childhood movies, calculus is used to calculate the shapes and make it seem real. A graphic artist uses calculus to determine how different 3D modules will behave subjected to rapidly changing conditions. Here, you can see a picture of a girl. Here, calculus come into play. The calculus is used to draw the hair of the girl. It makes the picture seem realistic. Now in this, I would mention the physics engine. What a physics engine is? It is a computer software that provides an approximate simulation of certain physics systems, such as rigid body dynamics, including collision detection, soft body dynamics, and fluid dynamics of use in the domains of the computer graphics, video games, and film. Here you can see a video clip. In this, a game is played where physics engine comes into play. Here, you could see the collision which occurred recently. The physics engine come into play and it shows the action-reaction pair. When the bike collides with the wall, it gets rebound, and when the man tries to kill the man, it also helps to know how much damage will go and how it will be killed. Now, I would show how it works. There is 4 bits. In the first bit, a structure is drawn. and some few straight lines are drawn to make it step B, and then a spherical type figure is drawn to make it the figure bit C, and a final touch is given to make C, and other touch are given to make a realistic face of a man.
Now we know how to calculate a circular area, a circle's area. But how to do the same thing with the help of calculus? Let's check it out. Here we have a circle. We have dissected it into a number of rings. Now, the width of each ring, the summation of the width of each ring is termed as capital R. And the circumference of the outer circle is 2 pi r. As you can see, an animation ahead. We will be demonstrating it with the help of a model. Check out Subham's screen. The circle is dissected into number of rings, where the summation of ring, that is R, is kept as a height and other are tried unfolded, thus making it a graphical triangular shape with a height as R and base as 2 pi r. Here is a colorful image. So here, as we know, since our childhood, the area of the triangle is half into base into height. Here we put the values half into r into 2 pi r. And alas, we got our result. It's our area. Before it was very tough to calculate the area of the circular rings and the circle. But this is the use of basic integration. With the help of this, we could easily calculate the area of the rings. So integration comes into play when there are tough shapes, curves, or non-Euclidean geometrical shapes. So now check out other applications.
Now let's move towards the application 7, finding maxima minima value. The maximum and minimum values of a function can be used to determine its boundaries in real life. For example, if you can find a suitable function for the speed of the train, then determining the maximum possible speed of the train can help you choose the materials that would be strong enough to withstand the pressure due to such high-speed brakes, and can be used to manufacture the brakes and the rails, etc. for the train to run smoothly. Here, you can see 3 pictures. In every picture, we found the derivative of it. And in the first picture, we found the double derivative of it, which comes as negative. That implies it is the maxima point. And in the second picture, the double derivative comes as positive, which shows that it is the minimum value. And the third, it is double derivative is equal to 0. Thus, it is known as inflection point, which represents a point at which the curvature is changing. So with this, we would like to sign out. Thank you. Hope you like our presentation, and we would be very welcome to the questions.
Okay, thank you, children. You had an impressive discussion with us because you are in class 10. Still, we hope that you have gathered some knowledge on calculus, or you just have gathered some information. I hope you know a little bit on calculus.
Yes, sir.
Yes?
Yes, sir.
Yes, okay. So let us come to pure calculus. I just want to know from you, you give an example of a function which is continuous everywhere, but not differentiable at exactly 2 points. Can you give a function, a real function?
Sir, that implies that after the derivative, either the down part comes as 0 or it 0, then we cannot differentiate. Means that implies that some equation will bring that that the bottom part after differentiating it will come as 0. For example, if we bring at 1 by x square, it is determined only at 1 point. Oh, then 1 by x square minus x square plus x plus 1.
No, I think you are not able to understand my question. My point was, do you know continuity of a function?
Yes, sir. Everywhere it is continuous.
Okay. Okay. So you know differentiability of a function.
Yes,
do
sir.
you agree that every function which is continuous is also differentiable?
Every function which is continuous is differentiable. Yes, sir.
Yes, sir.
Yes. So then what is the difference between continuity and differentiability? If every continuous function is also differentiable. Okay. So I asked you this question because you have given very good informations on applications of calculus, particularly this continuity and differentiability based on that. Okay. So if you are gathering some informations from net, Google or somewhere, you try to go through the mathematics part, because this is a seminar based on mathematics. So what is the exact role of mathematics? Let us not generalize the applications. Though a history student, a Odia student, Sanskrit student also can read all this. We should know what we are expressing, little bit on that should be known to us, the mathematics part. Okay. Anyway, at class 10 level, you have given so much.
Okay, so just a simple question. How to represent velocity using calculus?
So dx by dt.
Dx by dt.
What is S?
Displacement.
And how to represent acceleration?
Sir, dv by dt.
dv
Velocity.
by dt. Okay, great. Now, what makes the integral indefinite?
It doesn't has bounds, the upper and lower bound.
Upper limits and lower limit. It doesn't have.
In indefinite integral, there is no limit actually.
Yes.
Okay. Okay then. Thank you so much.
Thank you, dear, for your presentation. Moving on to the next project, that is the world in coordinates, which will be presented by Soumit Ranjan Hota, Asis Vikram Prishti, Pratip Das of 10D. Dear children, you can start your presentation. Kindly switch on your videos. The project name is The World in Coordinates.
There is no branch of maths which cannot be applied in our daily life. Good afternoon, respected judges, and all the healthy hearts present in this exhibition. I am Soumit Ranjan Hota. On behalf of my team, are going to make you aware about the different uses of coordinate geometry in our life. Now, before going to the uses, let us first have a small recap on its system. Now, well, the first one to develop this idea was René Descartes, was a French mathematician. Many other mathematicians from Greece and other countries have also thrown light upon this. Now, you must be wondering, what is a coordinate plane first? Well, a coordinate plane is a 2D plane formed by the intersection of horizontal x-axis and vertical y-axis. Now, we'll be seeing upon a formula which will be helping us further. Yes, it's the triangle formula. Now, we all know about triangles and its simple rule is half into base into height. But what if the coordinates of the triangle are given? Well, then the area will become half whole into x1 whole into y2 minus y3 plus x2 whole into y3 minus y1 plus x3 whole into y1 minus y2 if the vertices of the triangle are x1 y1, x2 y2 and x3 y3. Now let us observe some uses of it.
The applications of coordinate geometry are not only limited to formulas, they have some geographic uses as well. For this, a special system called the geographic coordinate system is used. This system uses longitudes and latitudes for defining the position of the three-dimensional surface of the Earth. Where we're sitting right now, 20 degree north, 85 degree east.
Now we all must have heard about GPS system, right? Like they're telling about the police, like get his GPS coordinates of him, track him, etc. Now, have you ever wondered how this GPS system work? Yes, it uses the coordinate system, but how? Well, it calculates the latitudinal and longitudinal distance to locate a place. Well, GPS can also be used to find an address, then find a remote place, then track someone. Well, for now, we have seen different uses of coordinate geometry in our life. Yes, it's about us, the urban people. But how is a rural person is going to get benefit from this? For that, we'll be seeing in a short period of time. Now let us observe some more uses before going to that.
Radar system.
the sky is a lot more crowded than it was in 1903. Then how do we share the sky safely? Now, flights obey a lot of rules and report the flight plans to the flight controllers, which then compare it to other flight plans and determine the shortest, safest, and quickest route. This radar takes the help of coordinate geometry and the time delay in receiving the signals to determine the position and the distance traveled by the aeroplane. Needless to say, without the help of the coordinate system, the air accidents would be much more popular.
Coordinate geometry is an essence of design, littered with blueprints, games, 3D models, and many more areas in graphic designing use the concepts of coordinate geometry. Now, how is coordinate geometry related to the digital world? I mean, it's a part of mathematics, but how we use it in the digital world? Let me to say you, coordinate geometry is an essential part of the devices without whom, in today's world, life is impossible. They are the computers and the mobile phones. Let's take a PDF file, which is very well known to us. PDF file is itself an example of coordinate plane. And what all we find in there? Words, text, shapes, they all are placed according to two-dimensional coordinate system, which consists of x and y axis. Let's take an example here. Here we have a shape of the square. Here it is on the coordinate plane and which has x-axis and y-axis. You will be amazed to know that the scanners and photocopying machines that we use also uses coordinate geometry to make an exact copy of the original image provided to it. Once a farmer of my village asked me how will he find the shortest distance between his house and his farm field. Well, I said, by using coordinate geometry. He said, how? So we'll know how to find the position of an object by using coordinate geometry. Coordinate system can be used to find the position of any object from its origin or original location to its present location. Let's take an example of the farmer. Let his house be on the origin and his farm field be here. Here we have the horizontal distance from his house to his farm field, which is on x-axis, and the horizontal distance on the left side on y-axis. Here we can, by using the both axes, here we can easily find the coordinates of the four vertices of the farm field. Here, as you can see, here are the four coordinates of the farm field. And now we can easily find the shortest distance by just applying distance formula. Not only this, we can also find the heights of 3D objects by using the z-axis. For example, we take of an TV or an oil barrel or a tent and even a pyramid.
Now, mathematics is not about just numbers, equation, algorithm. It's about our understanding. Now, using mathematics can be very useful in our daily life. So this was a small demo on how we can convert a theoretical topic into a practical way. Hoping that you would have liked it, I would like to conclude by saying that maths is omnipresent. Any questions will be highly appreciated. Thank you, sir.
Okay. It is Shomit and group. Let's take a general point xy. What is the distance of this point from x-axis?
So
Sir, why?
I couldn't get you.
Let us
Why?
take a general point xy. X coordinate is x, y coordinate is y, or say abscissa is x, coordinate is y. Then what is the distance of this point from x-axis?
So why?
Why?
Sir, why?
Okay, so your point is 2 minus 3. Then what is the distance?
Sir, from x-axis?
Yeah.
So -3.
-3.
So you are saying the distance is negative?
Yes, sir.
Okay then. Thank you. In fact, distance is never a negative quantity. It is a positive quantity. So the distance is not
it will
minus
be 3
3.
units from
Sir,
In fact,
in
x-axis.
Yes.
So it will be 3 units from x-axis.
I couldn't get you. Can you please repeat?
Sir, it will be 3 units from x-axis. As you told that distance cannot be negative, so it will be 3 units from the x-axis.
So we know
Distance.
coordinate geometry has different signs for all, like from minus negative y-axis, then negative x-axis. For that, the 3 units will be from the distance from the x-axis. Not negative can never, and distance cannot be negative.
So use sign convention here.
So now, how can you generalize it? You are saying that it is never negative, so you are taking negative of it. So if xy is a general point, how can you generalize the distance from x-axis, distance from y-axis? Is there any mathematical function we'll use here? Do you know modulus of a function, absolute value of a function? Absolute value of a function, absolute value of a number.
Yeah. Yes, sir.
Okay, that is
So
what
about
we
those. So about those bars, where if inside the bars, if it is a positive or negative, inside it is the bar, then absolute value will always be positive.
Okay. Okay, thank you from my part. Can you tell me how x is equal to 1 will behave in coordinate geometry? X is equal to
Sir,
1.
it will be 1, 0, where it will lie on the x-axis.
How the graph will be?
Sir, it will be a
It will
linear
be parallel
equation.
to y-axis.
Sorry?
Yes, sir.
One of you can answer.
Sir, it will be parallel to the y-axis.
It is what?
Just a ray.
Sir, sorry?
Sir,
Sir, it is a straight line.
a straight
It
line.
is a straight line. Is it always a straight line? Suppose I don't accept it as a straight line. Do you have any other alternative answer? Suppose I say, no, it is not a straight line. Then what you will say? Think about it, because you are discussing about a space also. X, Y, Z. I never said in XY coordinate, in coordinate geometry. So think about a plane and correlate that with this equation. Thank you.
You're welcome, sir.
Thank you, dear children, for your presentation. Moving on to the next project, that is Fun with Maths, which will be presented by Snehasri Shahu, G. Parinika, Pratyasa Das of 9C. Dear children, be ready. Snehasri, G. Parinika,
Ma'am, is the
and
video,
Pratyasa
audio and
Das.
screen clear?
Yes.
As stated by Shakuntala Devi, without mathematics, there is nothing you can do. Everything around you is mathematics and numbers. A very good afternoon to one and all. Today, I, Snehasri Sahu, along with my team members G. Parinika and Pratyasha Das, are going to present our project on the topic Fun with Maths. Here we will see how maths can be made fun using probability. Now, what is probability? Probability is a branch of mathematics consisting of numerical description of how likely an event to occur or how likely is it true. The probability of an event is always between 0 and 1. 0 indicates impossibility and 1 indicates certainty. Talking about its type, there are two types of probability, theoretical and experimental. Many terms related to probability are impossible event, sure event, and complementary event.
Moving towards the applications of probability, probability has wide range of uses in our daily life. In weather forecast, meteorologist experts use probability to finding out the weather conditions over an area by looking towards the past climatic conditions on that area. When sports strategies, be it football or basketball, are coin toss, and both the teams have 50-50 chances of winning the same. In insurance companies, use the probability to finding out the probability of happenings so that they can determine their insurance premiums.
Even though we do not realize the use of mathematical probabilities in everyday life, subconsciously we use it in every step that we take. The probable is what usually happens, said by Aristotle. It is a simple fact that the future cannot be predicted. However, mathematics can help determine its probability and how likely something might occur or not. Thus, the easiest definition is that probabilities are numbers between 0 and 1 and including them which specify the chance that something happens.
Now we have presented a model showing different games where probability is used. First, let us see for Casino. Casino is a very famous game where probability is being used. Here, the player selects a number, and if the same number appears on this wheel, then he wins the game. Let's suppose I select the number 5. The probability of getting 5 in this wheel is 1 by 10. First, I will roll the marble in this slide and spin the wheel. If I get 5, I will win. So let's see. As you can see here, I got the number 6. So I lost the game. In real casino games, the wheels are made much more bigger and the numbers are often repeated. Let's suppose I would have taken 20 numbers and 5 would have been repeated 4 times. Then the probability of getting 5 would have been 4 by 20, which is 1 by 5.
Now, probability is not only used in casino, but also in many other games. For example, in snakes and ladders, which we have been playing since our childhood, probability plays a very vital role. Here, we roll a dice and to go to the next move. Here, dice is a very common example of probability in our daily life.
Now that we have known what probability is and its applications in our daily life, we shall move on to the quiz, which consists of 3 questions. So the first question is that, find the probability that a leap year has 52 Sundays. Option A 3 by 5, option B 2 by 7, option C 9 by 13, option D 5 by 7. Which option do you want to choose, sir?
Sir is choosing B.
Sorry, sir, that's wrong. Sir, shall
Yes,
we move
sir
on
is
to
asking you to prove it wrong. How it is wrong?
So, ma'am, we will go to the solution then. Sir, as it is asked in the question that we have to find the probability of 52 Sundays in a leap year. So, we know that in a leap year, there are 366 days because in February, that's an extra day, that is 29th of February. So, in a leap year can have 52 Sundays or 53 Sundays. In a leap year, there are 366 days, out of which there are 52 complete weeks and remaining 2 days. We can get that if we divide it by 7, the number of days present in a week. Now, these 2 days can be Saturday, Sunday, Sunday, Monday, Monday, Tuesday, Tuesday, Wednesday, Wednesday, Thursday, Thursday, Friday, and Friday, Saturday. So there are total 7 cases, out of which Saturday, Sunday, and Sunday, Monday are 2 favorable cases. So the probability of 53 Sundays is equal to 2 by 7. Now that we have seen earlier in the PPT that complementary event is a term related to probability, the complementary event now comes in use in this question. The probability of 52 Sundays plus probability of 53 Sundays is equal to 1. So probability of 52 Sundays is equal to 1 minus probability of 53 Sundays. If we solve further, the answer comes 5 by 7. That's the answer, sir.
Now we will move to the next question.
Please
Find
let
the
us, please hold
probability
on.
of getting an...
We are
Sorry,
all
sir?
happy with your presentation. Carrying on to that probability, I have a small question. Suppose you are tossing a coin 3 times. Okay, 1 coin 3 times. Tell me the probability of getting at least 1 head. Any one of you can answer.
Sir, as we are tossing the coin 3 times, so the total outcome will be 6. Getting at least 1 head will be, in the first case, we can get 1 head.
How the sample
The
space
second
is
case
6.
also we can get 1 head.
First, you please explain the sample space. How it becomes 6? 2 plus 2 plus 2.
Yes, sir.
Yes. Dekho. See, these are very simple questions and you are tested. Always think about the mathematics part. What you are going to represent, you must know the real mathematics behind that. You're talking about probability, very good examples you have marked up, but you don't know the sample space. So if you are tossing a coin once, then sample space becomes 2. If you are tossing twice, sample space becomes 4. If you are tossing 3 times, sample space will be 8. If you understand the mathematics behind the principle of addition and multiplication, then you will get an idea about calculating the sample space. From there, you can find out. Okay, there are nine competitors today. What is the probability that you will win the first prize?
So 1 by 9.
Okay, very good. Ijjat rakhe.
Thank you, my dear children. Thank you, everyone. Okay, let us move to the next presentation. The project name is The Pirates Fun with Solids, which will be presented by Priyansika Sahu of 9F. She is a solo presenter. Okay, you can start. Yes? Okay, start. She is a solo presenter.
Pranam, I am Priyanshika. I welcome you all to my presentation, The Math Pirates Fun with Solids. In the real world, whatever we can measure can be managed. In the huddled and bundled classroom, it is indeed difficult to make complex theoretical concepts very clear. Working models help in developing the habit of critical thinking and logical reasoning, which are most important in mathematics learning. Now I'm going to show you two simple math activities which have wide real-life applications. A good understanding of these two math ideas can help us in making informed decisions. All of us know that volume is a measure of how much a figure can hold, or we can say that volume of an object is the amount of space enclosed within it. For my first activity, I have chosen two solids. One is a cone and the other one is a cylinder. We know that a cylinder is a solid generated by rotating a rectangular sheet of paper lengthwise or breadthwise about its axis. And a cone is a solid generated by rotating a sheet of paper that is a right angled triangle in shape about its sides. Now we know that a cylinder is a regular solid, so we can find its volume by multiplying its base area into its height. But a cone is an irregular solid, so we need to compare it with some other regular solid so that we can find its volume. Thus, a cone can be compared with a cylinder so that we can derive its volume. As you can see here, we have a cone and a cylinder. The height of these two are nearly the same, and also the radius of the top of the cone and the cylinder are equal. Now I have a question for you. If we fill the cone with sand and empty it into the cylinder, how many times do we have to fill the cone completely so that it fills the cylinder to the top? The answer is 3. Now, let us see how. So this is the first term. This is the second one. And this is the third time. As you can see here, the cylinder is completely filled till the top. So this shows us that a cylinder has 3 times the volume of a cone with the same radius and height. Now let us move on to my next activity. So another important aspect of every solid that we should look into is the surface area. Surface area, that is the measure of the total area that the surface of the object occupies. So for my next activity, we have taken a plastic ball, cut it into 2 halves. Cover the circular face. We find out its radius and locate its center. We take a thread and rotate it till it completely covers the circular face. Now we take out the thread, use a measuring tape to find the measure. So I have taken the measuring tape and I'm measuring it. Here, as you can see, it is approximately 50 cm. Now we repeat the same steps with a curved surface also. I've covered it completely with thread. We take out the thread, take the measuring tape and start measuring. So for this one, we have a 50 cm here. And this gives us our next 50. So 50 plus 50, that is 100 cm. So what is our observation then? The length or measure of thread that covered the flat circular face was 50 cm, but the length of thread that covered the curved surface was 100 cm. So this leads us to the conclusion that in a hemisphere, the curved surface area is twice the flat surface area. Now, these two activities may seem too simple, but the knowledge that we gather from these two activities have a wide real-life applications. Certain things that we use in our day-to-day life have not been questioned yet. Have you ever wondered why do the pipes that carry water to your houses are cylindrical in shape and not rectangular or square? Let me explain. Let us take 3 pipes, each having a circular, a square, and a rectangular face. Let us assume that their perimeter is 44 cm each. Now, I have a question for you. Will each of these pipes, which are of the same length obviously, supply the same amount of water in a given time? The answer is a big no. This is because we find that the area of the square, if the perimeter is 44 cm, is 121 cm square. The area of the rectangle is 120 cm square, whereas the area of the circular face of the cylindrical pipe is 154 cm square. Now, I see a great difference here in their areas. So this leads us to a conclusion that a circle has the highest area by perimeter ratio, or simply a circular cross-section pipe or a cylinder can supply more water in less time. It also allows the largest volume to be contained for a given material used to construct the pipe. There are no sharp edges, so there is no problem in its construction, and it also helps the pipe to withstand higher pressures. And finally, since the surface area is least as compared to any other solid, the frictional losses, that is wear and tear due to friction, will be lesser. Thus, the pumping required will also be lesser. So with this, I have reached to an end of my presentation. Thank you.
Okay, can you please tell about right circular cylinder? What is right circular cylinder?
So a right circular cylinder is when a cylinder has circular bases and its base is perpendicular to its axis.
Okay, and what about right circular cone?
Sir, the same happens with the right circular cone also. Sir, here we have a cone. So the base is perpendicular to the apex. The base is circular. For circular right circular cylinder, the base is circular and the base is perpendicular to the apex.
And the one point is, can you please give one example which is not right circular, whether it is cylinder or cone? Just give one example which is not right circular.
Sir, if we stack up a pile of CDs and keep it in a slanting way, it doesn't make a right circular cylinder. But if we stack them according like this, then it will make a right circular cylinder.
Very good. Very good.
Thank you so much for your presentation.
Thank you.
Okay, fine. Moving on to the next project, that is Battle for Triangles, which will be presented by Vipai and Jenna, Subrajit Pradhan of 9E.
Ma'am, are we audible and visible?
Yes, you can start.
Okay, ma'am. Yes, ma'am, sure. Ma'am, is the screen visible?
Yes, it is visible and audible.
Okay, ma'am.
You can start your presentation.
Yes, ma'am.
A healthy and warm afternoon to all my teachers and my dear friends present in this virtual platform. Today, I, Subrajit Pradhan of class 9E, along with my friend
Deepa and Jena of class 9E.
Sorry for interruption. Be little louder.
Okay, ma'am. Louder.
Welcome you all to our mass project display on the topic Battle for Triangle. Many of you might be thinking about what battle am I talking about? Well, friends, in our project display, we have taken one of the theorem of the chapter triangles and will be proving it with some activities. Hope you all will enjoy. We all know that remembering some of the math theorems are a bit difficult, but what makes it interesting is making it practical based and understandable. One such theorem is proving that the sum of two sides of a triangle is greater than the third side. So without wasting much time, let's move on to the proof. This is the proof of the theorem.
Now, let's move towards the activities and have some fun there for the theorem which we have selected. Let's move on towards activity 1. Here, as you can see in the given figure also and in our video, we have taken one cardboard base with 3 pins stacked to it, which are the green pin, red pin and the blue pin. Let them be A, B and C point respectively. If we'll be attaching one string starting from point A to point C through point B, we'll be getting that the string is of the perfect length which we have selected, that is the string is of the length AB plus BC. Now let us consider another case. Now let us add one string directly from A to C. Now when we'll be adding one string directly from A to C, we'll be getting that some part of the string is still left out. This proves that the sum of two sides of a triangle are greater than the third side. Now let's move on towards activity 2, which is a practical based activity. We all have come across such type of things in our day-to-day life. Let us consider one boy, let be Aman, who was walking on the road when he found one of his friend Anand on the field. Let Aman was at point A and Anand was at point C. So what path will he take to reach Anand faster? It's quite easy, guys. He will take the path from A to C to reach Anand faster. Now let us consider another situation. Let Aman will take a path from A to B and then from B to C to reach Anand. So guys, he has to cover a much more distance than covering the distance from A to C. So as the figure, the distance he has taken is in a triangular shape. So you can say that AB plus BC will be greater than AC, as he has to cover much more distance than covering the distance from A to C. Now let's have a look of some of the applications of this theorem in our day-to-day life.
Mapping features such as MapQuest and Google Maps use triangle inequalities to calculate unknown distances when you drop in locations or pins to plan a trip. The software applies the triangle inequality theorem to determine the distance between unknown places. Without triangle inequality, no triangle is possible. Another example of triangle inequalities can be seen in the ancient pyramids. The ancient engineers had a quite good knowledge of the triangle inequality theorem as they constructed well-shaped and sized pyramids. An example would be the edges of my Christmas tree star, because if the measurements were inaccurate, then the points of the star would not form proper triangles. Also, a triangular shaped notebook wouldn't be a triangle if its measurement didn't suit the triangle inequality theorem. To make perfect triangles, we need to follow the law of inequality.
With this, we come to the end of our presentation. With the hope that you would have learned something out of it, we would like to conclude. Thank you, and questions from your side will be highly appreciated.
Okay, thank you. Thank you, boys. Can you just tell me the construction process of drawing a circle inside a equilateral triangle? I want to draw
Okay,
a
sir.
circle.
Yes, sir. So what we can do is that we can take 3 points. So if we take 3 points on it, then you have to construct them. If we take, for example, let me show this. So these are the 3 edges. So if we'll take this distance and this distance, we have to find the midpoint of these lines. Then we have to draw the perpendicular between these 2 lines and we have to find the midpoint. The line where the point where they intersect will be the midpoint. And then taking the radius as from the point to any of the edge, we can just construct using it the circle.
And what is that point is called for the center with
It's a
reference
radius.
to the center?
Sorry, sir?
What is the name of that point with reference to this circle? Is it in center?
Sorry, sir, we can't hear you actually.
I want to name that point.
Okay, so means the middle point, this one. Yes, sir. So yes, sir, we can name it as.
What is the name of that point?
So the middle point, right?
Okay.
Actually, the intersection of the bisectors, what you are telling there, the bisectors, the intersection of the bisectors.
No, sir, perpendicular bisectors. Yes, sir, bisectors. Perpendicular ones.
So where they intersect, tell me the point. What's the name of it?
Sir, the center of the circle.
Yeah, there is a specific point name, no?
Sorry, sir.
Okay. Can you please guess?
Center of the circle and.
Yeah, center of the circle, but there is a specific name to it. Okay, so we'll discuss that. And you are discussing about inequality. Let
Yes,
us
sir.
take a point which is external to a line. Now, can you prove that the perpendicular is the shortest?
Okay, so means you have to you are telling that we have to take one line and from a means this is a line. So here we take a point. So you have to find that this perpendicular is the shortest one, right?
Yeah.
Okay, sir. So for example, if we take one line and here is the point, so if we take the perpendicular and let us take some more points on the line. So if we'll draw the line from the point external and to the lines which I have drawn, then we'll get a right angle circle. So as we know that the hypotenuse is the shortest shortest, what can you say, the shortest side in a right angle. So there, as you're taking a perpendicular to the lines, we can say that it is the shortest one.
Okay. And since you are using Google Map in your presentation, can you please tell me Indian version of Google Map?
Indian version of Google Maps.
Yeah. Okay, you can try Bhuvan.
Actually, sorry, we don't
Yeah,
know about it.
Bhuvan,
But
there is very interesting features are there. You can browse it and you can get it. And regarding
Sure,
the intersection of the perpendicular bisectors, it is circumcenter.
Okay, sir. Okay, sir.
Thank you.
Thank you, sir.
Thank you everyone for your wonderful presentation. With this, we come to an end of the mathematics project display presented by senior group. After few minutes, we will start the project display for junior group. Stay tuned for junior maths project display. Thank you all.
his PhD on delay differential equation and has publications of more than 20 journals in national and international level. We welcome you, sir. Then Dr. Kanan Kumar Patra, PGT Mathematics in Kendriya Vidyalaya 3. He has completed his PhD from KIT University and he is having 20 years of teaching experience as a mathematics teacher. We welcome you, sir. Without any delay, let us begin the first presentation. Before just starting the project display, let us know the rules and regulations of the presentation. Each group will have a maximum 4 members and we have some solo groups as well. Each group will be given 7 minutes time and each group will be awarded from 50 marks. Again, the 50 marks are divided for presentation 10 marks, mathematical concepts 10 marks, model or charts 10 marks, innovative applications 10 marks, question answer 10 marks. So in this way, the 50 marks you will be getting. Now, I think I am clear and all my participants are clear about the division of marks. Without any delay, let us begin the first presentation. Now, the first group is from class 8 and the topic division of polynomials by dot patterns. And the group members are TN Pratyus and Swadhin. So may I request TN Pratyus and Swadhin, yes, to start the presentation.
Good afternoon, everyone. I am TN Pratyush and this is my friend Swadhin Mishra. And today we two are going to describe on the topic division of polynomials using dot method. So first of all, we will share our PPT. So before going to polynomial, let us look on to maths. So what is basically maths? Mathematics is the science that deals with the logic of shape, quantity, and arrangement. Maths is all around us in everything we do. The needs of math arose based on the wants of the society. The more complex a society, the more complex the mathematical needs. The most interesting thing about it has a proof for everything. It helps us to explore our surrounding in a better way by learning the applications of maths in our daily life. So now let's talk about polynomials. So polynomial is an expression of more than two algebraic terms, especially the sum of several terms that contain different powers of the same variables. So now let's talk about an example, 5x squared plus 2y minus 7. And here 5 and 2 is coefficient, x to the power 2. Here 2 is the exponent and 7 is the constant. Now let us look on to the uses of polynomials. We can find the quantity and quality of things we purchase where quantity is same but price varies. For finding the cost of milk or any liquid substance, economists use polynomials to model economic growth. To interpret and forecast market trends, it is very much useful in mensuration also. It helps us to find perimeter and area of various shapes. For example, if side is x plus 1, the perimeter will be 4x plus 1, that is 4x plus 4. So now we are going to learn how to divide a polynomial by using beads. The materials required are a chart paper, ruler, sketch pen, and some beads. Procedure: make 6 boxes on the upper side and 3 boxes in the lower side of the chart paper. So now my friend Swanin is going to explain you how to divide polynomial by using bead method.
TN Pratyus, please see that your video is on. Audio also you make it on, please. You are not audible.
Ma'am, we are audible now?
Yes, yes. Thank you.
Ma'am, so now, ma'am, this is our project. And first of all, Swanin is going to explain this one, this example. X square plus 3x plus 2 divided by x plus 2. So, Swanin.
So this is the numerator part and this is a denominator part. This is the ones box, this is the x box, this is the x square box, this is x cube box, this is x to the power 4 box, and this is x to the power 5 box. And the denominator part, it is written ones box, and x square box. So the first example is x square plus 3x plus 2 divided by x plus 2. So here it is 2. So in one column we will put 2 dots. Then 3x, in x column we will put 3 dots like this. Then x square means x square column will put 1 dot. Then comes the denominator part. It is written x plus 2 means in x plus we will put 1 dot and 2 in ones place. So as we cancel the terms in division method, we will also form patterns and cancel it by ones. So here I get a triangular pattern like this, and I will also do this pattern in the numerator part like this, one pattern, and like this another pattern. In your mind, a question will arise that why this can be a pattern. This can be a pattern because this pattern is facing this side and this pattern is facing this side. So it can be a pattern. So I will now remove this pattern by a black dot like this and like this. So after replacing, the answer came as x plus 1. So now TN will say you another example. TN, please. Yes. Now we see this one, x cube plus 3x square minus x minus 3 divided by x plus 3. So we know this is the numerator box and this is the denominator box. So the numerator x cube. So coefficient of x cube is 1. So we put 1 red dot in x cube. Then plus 3x square. So coefficient of x square is 3. So we put 3 dots. And then minus x. So for minus we will use a black dot. So minus x and minus 3. And minus 3 means we will use 3 black dots. Now in the denominator part, it is x plus 3. So both are positive. So x plus 3. So now we will try to form a pattern so that we can cancel it. As in division, we also try to cancel the terms in order to get the quotient and the remainder. So here we will try to form a pattern like this. And here we get a triangular pattern, this one. This triangular pattern. So we will also form here in the numerator. So here we also get a triangular pattern. Like this, here is a triangular pattern. So it is just like this pattern. So we replace this one. We replace this one by one red dot. And this triangular pattern, this is the negative triangular pattern. So we'll replace this one by a black dot. So we get the quotient as x square minus 1. So when x cube plus 3x square minus x minus 3 divided by x plus 3, the quotient is x square minus 1. Thank you. And we conclude that this process is quite easy and reliable. This increases our logical thinking and creativity skill, and we can explore more about maths by doing this project. Thank you. And we expect questions from your side. We recommend questions from your side.
Okay, thank you. Why you have kept one single dot under x square in the last example? Why not in the x column?
Sir, in x square?
Yeah.
Sir, after the division you're saying, no? Sir,
yes.
Because it got cancelled. Sir, like this I'm showing you. Sir, the pattern was like this, I told. Sir, the pattern was quite like this. So we see the pattern like this. In division, what we do? We cancel the term by the one term. So we cancel this one by one whole red dot by here. Because this one is here, so this triangular pattern will cancel and put one red dot here.
Now why here? Why there?
Because it is getting cancelled in x square column.
It is cancelled in x square column. I'm not convinced.
Sir, because we see here in the pattern is a triangular pattern. So when this will get cancelled, it will form in the predecessor box. Sir, this one. Sir, always this box.
Okay, don't you think it rather it becomes little bit difficult for students at this level, rather they should prefer the orthodox style of division like you people are doing in the class? What
Sir,
is the advantage of this method?
that is we're telling that this one, sir, this one if we will do, sir, we will get much clarity about division, how we cancel the terms, why we cancel the terms.
Okay.
You are dealing with polynomials. So whether x plus 1 by x is a polynomial?
Yes, sir.
Okay, what
Sir,
is the
x
degree
plus
of it?
1 by x. Sir, you told x plus 1 by x.
Yeah.
No, sir, it is not.
What's the reason this is not a polynomial?
But because x plus 1 by x. So when we will divide, sir, you know, sir, x plus 1 by x means x by x plus 1 by x. Yes, sir. Then x by x will become 1. We'll cancel then 1 by x. In 1 by x, we see the power of x is minus 1. But in polynomials, the power should be always a positive one, not negative.
Okay, so it's always positive.
Yes, in polynomials, the power of the variable should be positive.
So we have zero polynomial?
Yes, sir. 0.
Can you please give one example of a polynomial which is called a zero polynomial?
5. Sir, the constant terms.
That is constant polynomial, no?
Yes, sir. That is the constant polynomial. 0 polynomial is 0.
Okay, zero polynomial is 0. Now, how many zeros are there of a zero polynomial?
Sir, how many zeros?
Zeros, you know, the roots.
So that roots of the equation.
Yeah, polynomial,
Yes,
roots of a polynomial.
Sir, infinite.
This thing? Whether you know or not.
Yes, sir. It is
Because
infinite.
it is in higher class, so whether
If we will put any value of x, then it will always become 0.
okay. What is the degree of a polynomial?
Sir, degree is the highest power of any variable.
Highest power. Okay, great. 2x square plus 3y square plus 2xy square. This is a polynomial. 2x
Yes, sir.
square plus y square plus 3xy square. So this is a polynomial in two variables. What is the degree of this polynomial?
3.
3. So how did you get it, this 3?
Sir, because in the last time we see 3xy square. So the power of x is 1, power of y is 2. Sir, here the powers will get added. Where there are two variables, the power will get added. So here power get added, 1 plus 2 is 3. So it is the highest degree, so it highest power, so it is the degree 3.
Okay, thank you.
Welcome. Thank you, sir.
Thank you, students. Moving on to the next presentation, it is geometrical representation of algebraic identities, and it will be presented by Debansh Pani, Arman, Asutosh, and Swadesh Dev.
Sir, are we audible?
Yes, audible. On your video.
Mathematics is the language of logic. Without it, no computations are possible. A warm afternoon to everyone present over here. This is Devansh Pani along with my teammates Arman Mohanty, S. Swadeshdeep Anand and Ashutosh Sai. So today we have came up with our project which is the geometric verification of algebraic identities. So let's know what is an algebraic
May I
identity.
interrupt?
Yes,
Little brightness you give better.
Ma'am, in my face.
Face is little bit coming dark. The room is coming dark. So either you switch on the light or make it little brighter.
Okay, ma'am, 1 minute.
Yes. It's all right.
So this is Devansh Pani along with my teammates S. Swadeshdeep Anand, Arman Mohanty and Ashutosh Sai. So today we have came up with our project which is the geometric verification of algebraic identities. So let's know first what is an algebraic identity. So an algebraic identity is a statement of equality which holds true for any value of variable which we keep on both the sides. For example, a plus b whole square is equal to a square plus b square plus 2ab. A minus b whole square, which is a square minus 2ab plus b square. So like this, my friends have done the geometric verification. So in what ways identities are helpful? They are helpful to compute the square or cubes of large numbers, such as what is the square of 105? It seems difficult. You would always obviously opt to use a calculator, or you would pick pen and paper, but identity made it easy. Let us know why. Because 105 square is 100 plus 5 whole square. As we know, a plus b whole square, a square plus b square plus 2ab. We can expand like that, which is 100 square plus 5 square plus 2 into 100 into 5, which comes to be 11025. So like these identities are helpful to us in many ways. So we have chosen two of the identities to do the geometric verification, which is a plus b plus c whole square and a plus b whole cube. So first, Astos is going to explain you about the geometric verification of this identity, which is a plus b plus c whole square. Astos, please, as you can see here. Astos, you have muted, please.
Asutosh, please unmute yourself. Asutosh, please unmute.
Good afternoon, everyone. My name is Astos of class 8D. Now of DAV Public School Chandrasekharpur. Now I'm going to explain my project. So you can see this is a square. The length of the side of this square is A. So the area of this square is A square. Now you can see this is a big square. The length of the side is B. So the area of this square is B square. Here you can see there is also a square of the length of the side is C. So the area of this square is C square. Now you can see these two rectangular bases are congruent. So the length and the breadth will be equal to each other. Here the length of this rectangle is B and the breadth of this rectangle is A. So the area of two rectangles will be AB. Now you can also see this is a rectangle. These are also rectangle and congruent. So their length and breadth will be equal to each other. Here the length of this rectangular base is B and the breadth of this rectangular base is C. So the area of two rectangular base will be DC. Now you can see these are also rectangular base of length C and breadth A. So the area of this rectangular base will be CA. Now you can see I have formed a big square. The length of the side of this square will be A plus B plus C. As we know, the area of the square is side into side. So the area of this big square will be A plus B plus C into A plus B plus C. That means A plus B plus C whole square. That will be equal to A square plus B square plus C square plus 2AB plus 2BC plus 2CA. Thank you.
Thank you, Astos. As he has explained the geometric verification, so here in the screen also you can see the theoretical verification, which we can get by just by multiplying these two. Now my friend Arman Mohanty is going to explain you about the geometrical verification of the identity, which is A plus B whole cube. Arman, please.
Good afternoon, everyone. I am Arman Manti of class section 8C. So today I am here to represent the geometrical verification of an important identity, that is A plus B whole cube. So as you can see that here I have taken a bigger cube whose edge length is A. We all know that the sides of cube are same, so the volume will be A cube. Here I have taken another type of cuboid whose length is A, breadth B and height A. I have taken three similar kinds of cuboid. You can see. So the volume of each cuboid will be A square B. Here I have taken another cuboid whose length is
May
B.
I interfere here?
Yes, ma'am.
Please stop your virtual background. Virtual background should not be there.
Ma'am, is it okay?
Yes.
Ma'am, okay. So you can see that here I have taken another type of cubed whose length is B, breadth B, and height A. Similarly, in this case also, I have taken similar cubeds of this kind. So the volume for each cubed will be AB square. Here I have taken a small cube whose edge length is B. So the volume will be B cube. Now I am going to assemble this all cubes and cuboid. I am going to put this in front of the bigger cube. This one above of this. This one over here. This one here. So, as you can see that here I have assembled all these cubes and cuboid and I am getting a bigger cube whose edge length is A plus B. So the volume of this bigger cube is equal to the volume of these small cubes and cuboid, that is A square B plus A square B plus A square B, that is 3A square B, plus AB square plus AB square plus AB square, that is 3AB square, plus B cube, that we have taken the smaller cube's volume, plus A cube, that we have taken the bigger cube's volume. So A plus B whole cube is equals to A cube plus B cube plus 3A square B plus 3AB square. Hence here I have proved the formula of A plus B whole cube. Thank you.
Thank you, Arman. Now my friend Swadesh Anand is going to explain you about the daily life application of these identities which my two friends told.
Good afternoon. Now I'm going to explain you about some more application. Suppose you want to multiply
Louder.
two large numbers. Say,
Be louder.
suppose you want to multiply two large numbers, say 991 and 1003. If you know the identity, it can be solved on pen and paper without much effort. Identity helps us to factorize an polynomial equation and simplify it in a shorter and easier way. Many everyday situations can be modeled into mathematical equations. Identities provide a way to factorize those equations and simplify them. So maybe you are not directly using them, but somewhere behind the scenes, someone has definitely used them and made our life easy.
As Swadesh told some applications, now I'm going to tell you about more and how it is related to our day-to-day life. According to math, identity is an equality that holds true irrespective of values which we choose of variables, as I told you. But in life, the identity is what we strive for it which we work day and night, and we struggle and always give our best. As in maths, the identity holds true irrespective of values which we choose. In life, to make our identity, we have to maximize our strengths, minimize our weakness, and always stay focused in life for to get success. Life is like a mathematics equation. In order to gain the most, you have to know the most and you have to give the most. 99% of perspiration plus 1% of inspiration leads to 100% success, which means that life is only 1% what happens and 99% what we do and what we give to achieve success. So,
Okay,
sir. Thank you, sir.
Thank you so much, boys. You have experimented geometrically how A plus B plus C whole square can be verified. Can you do that for A plus B minus C whole square? A plus B minus C. Suppose I want to find out. Is it possible, Asutosh?
No, sir.
No?
Sir.
Then what is the use of doing all these hard work for only for A plus B plus C whole square or A plus B whole cube?
Sir, it is easy to find the identity.
Yeah,
It will
A
make
plus B
easier.
minus C whole square is not an identity.
Yes, sir, it can be.
It can be. Can you show it quickly?
Sir,
How? Dekhiva. You will see it afterwards. Huh?
Yeah, since you are using A plus B whole square and all these things, can you quickly please tell what's the product of 107 into 93?
Sir, 107 and
Into 93. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 107 into 93.
Sir, it's 9951.
How did you get it?
Sir, we use the identity x plus a into x plus b.
X plus?
X plus a into x plus b.
Can you please tell what is X, what is A, what is B?
Yes, sir. Here, as you have told that 107 and 93. Here, x is 100, which we have taken as the main, the base. And as we know, x plus a into x plus b, which is x square plus a plus b into x plus ab. So 100 square plus a, and here our a is 7 and b is minus 7. So if we put the values there in the equation, we get it as 9951 after computation.
Okay. In different way, can you do it?
No, sir. Actually, I know this way only to
yes,
do
that
it.
Yes, that is the only way. So that is, you have taken 7 and minus 7.
Yes, sir.
By taking 100 as base, you can take plus 7, minus 7. So you will get a plus b into a minus b. That also you will get.
Yes, sir. We can do also that. A
The
square
process
minus
is
b square.
correct.
Yes,
Okay,
sir.
thank you so much.
Thank you, sir. Thank you.
Thank you, dear students. Moving on to the next project. It's linear equation by activity method. And the group members are Ananya Mahapatra, Sibangi, Adyasa.
Good afternoon, one and all present over this virtual platform. Myself, Adyasha Sahu, and here are my project mates, Ananya Mahapatra and Shivangi Menon. We all are from Standard 8, Section D.
As we all know, because of the ongoing pandemic, we're presenting our ideas through the virtual platform for the first time. Mathematics is a subject which is very interesting and is the building block of everything in our daily lives. Let's see a situation of our daily life.
Platform.
That is,
Myself, Adyasha
once in a
Sahu,
park,
and
two
here are
brothers
my
and a friend
project
of the
mates,
elder brother
Ananya
were playing
Mahapatra
with each
and
other.
Shivangi
While
Menon.
playing,
We
the
all
elder
are
brother
from
told his friend that his brother was of 5 years and asked that my age divided by 4 added with 2 gives my younger brother's age, and asked his friend to find his age. So to solve these kind of problems, we can use the concept of linear equations. When we hear the term linear equations, the first question that arises in our mind is, what is a linear equation? A linear equation is an algebraic equation in which each term is either a constant or the product of a constant and a variable. The second question that arises in our mind is, how do linear equations help us? Linear equations help us translate our daily life situations into a mathematical statement. They also help us solve age problems, speed, time, and distance problems, as well as money problems.
The third question that arises in our mind is, why are we doing this activity? The answer is that normally in our daily life, many students face problems in solving linear equations. We mostly use trial and error method and transposition method. So to make the concept of solving linear equations more easy, interesting, and understandable, we have chosen to do this activity.
The question which Shivangi mentioned earlier can be solved more interestingly by using our activity. So, first of all, we need to convert the statement into a mathematical statement. So, after conversion, we get the equation as x by 4 plus 2 is equals to 5. Now, this whole blue colored big circle represents x. So, this quarter represents x by 4. So, here we have taken x by 4. Now, plus 2, represented by 2 yellow colored small circles, each representing plus 1, is equals to plus 5, represented by 5 yellow colored small circles. Now we get the equation as x by 4 plus 2 is equals to 5. As we are solving a linear equation, we need to cancel the terms on both the sides. So to cancel the plus 2 in the LHS, we need to add here minus 2, represented by plus 2 is equals to 5.
two green colored small circles, each representing -1. So we are solving a linear equation. So we also need to add -2 in the RHS as well, as it is a rule that whatever you add or subtract in one side, you have to do the same on the either side also. So here in LHS, these get cancelled, and in RHS, these get cancelled. So we are left out with x by 4 is equals to 3. Now to make this quarter a whole, we need 3 more quarters, which is nothing but 4 times of x. So here after arranging 3 quarters, we get x in the LHS. And here RHS also small
You are not audible.
So here after adding more 9 yellow colored small circles, we get the solution of the equation x by 4 plus 2 is equals to 5 as x is equal to 12. So the age of the elder brother is 12 years.
To make the concept more clear, I have another example over here. The example is x by 2 plus 4 is equal to 6. Now, I would be taking this big circle as x. So I would be taking the semicircle as x by 2. Next, this yellow color small circles each represent +1. So I would be taking 4 of this to represent +4. Now, I would also require 6 more to represent +6 in the RHS. Hence, our equation is arranged. Now, to cancel this +4, I have to add -4. For that, I have this green color small circles which each represent -1. So I would be adding over here. So as it is a linear equation, there is a rule that whatever you add and subtract in the LHS, the same you have to do in the RHS as well. So here in the RHS, I would also add -4. Hence, this +4 -4 gets cancelled out. And these get cancelled out. Then I have left out with x by 2 is equals to 2. Now to make this as a whole, I have to add another semicircle to it, which is 2 times of first semicircle. As I'm making 2 times of the first in the LHS, same I have to do in the RHS, which is 2 times of 2. So for that, I have to add another 2 circles, which will make it 4. Now we got the solution that x is equals to 4.
Solving linear equations is one of the most important building blocks of mathematics. It allows us to solve for an unknown, which happens so often in our daily lives. So through this activity, we have practically learned the true uses of linear equations. That's all. We hope you like it. Thank you. We welcome any queries from your side.
Thank you. Thank you, Ananya and Sibangi and Adyasa. You have presented very well. Can you tell me when you are thinking about a linear equation, how it behaves geometrically? What is that? Suppose I want to plot that. So can you think of some type of graph geometrically how it behaves?
Sir, is it linear graph?
Yeah, linear means what? Linear graph means what? Is it
Sir,
like
linear
a circle?
graph means a straight line.
Very good. It is like a straight line. So suppose I will write x plus y is equal to 1. Is it a linear equation? X plus
Yes,
y is equal to 1.
But it is not in one variable. It is a linear equation in 2 variables.
Very good. So it is a linear equation of 2 variable. I know your entire project is based on single variable, which can be solved, and you have solved those equations in a different way. Very beautifully you have solved. Now my question is, can you solve this x plus y is equal to 1 also?
Sir, not
Possible.
by this activity method, but
Algebraically, you can do.
yes, sir.
Yes, sir.
Can you do it? Can you tell me x plus y is equal to 1? What is the solution?
সেটা দেখাওনি দেখাও
Okay, it is beyond your curriculum. When you are going to solve such type of equation, as you are using two variables, so you require two equations. Understand? Maybe in class 9 you will be discussing that. Good.
Okay, Ananya and group. Here is a question. One half of a number is 7. Then what is the number? One half of a number is 7. Then what is the number?
So is it 14?
Are you guessing or you are answering?
Sir, 14 by 3.
14 by 3? Or your partner is saying 14. You are saying 14 by 3. So which one I will consider?
Sir, 14 by 3.
Yes, sir, sorry, 14 by 3.
Can you please tell the method by which you got the answer?
Sir, actually we got the solution by using the transposition method, but we are
What do
here.
you mean by one half of a number? Is it one whole 1 by 2 or only 1 by 2?
Sir, 1 whole 1 by 2.
Okay. Anyone of your partner want to change it?
No, sir, 1 whole 1 by 2 only.
Yes, sir.
Are you sure?
Yes, sir.
I think you are guessing. Okay, so I am going to another question. Let us say difference of your teacher's age and your age is 20. Difference of your teacher's age and your age is 20. What will be the difference after 20 years? Difference of your teacher's age and your age is 20. What will be the difference after 20 years?
Sir, 20.
20. Okay, good. So you
Yes,
try
sir,
the
20.
answer of the first question.
Thank you so much, children. Our next project is rotational symmetry to be presented by solo participant Priyansi Das from Standard 7. Priyansi?
Ma'am, is my video correct or it is upside down?
No, correct.
Okay, ma'am, thank you. Good afternoon. This is Priyanshi Das, a student of Standard 7B. First of all, I would like to ask you a question. Could you say why Taj Mahal is considered as a beautiful monument and it is also considered as the seventh wonder of the world? If you are guessing the answer as symmetry, you are correct. Due to its symmetrical architecture, the Taj Mahal is considered so beautiful and also it was nominated as the seventh wonder of the world. So I hope from this you could guess the name of my project, that is on symmetry, and more specifically I will be explaining you about rotational symmetry. Symmetry is an important geometrical concept. It is found in both man-made as well as in natural things. For example, symmetry is found in leaves, flowers, honeycombs, stars, the full moon, sun, etc. Symmetry is categorized into two parts, that is, symmetry about a line and symmetry about a point. Symmetry about a line is also called as reflectional symmetry, and symmetry about a point is also called as rotational symmetry. So here I have a model prepared on reflectional symmetry. Here I have taken a piece of symmetrical drawing and I folded into two equal parts. Here is the line of symmetry, and now I will folding this flap upwards. I hope you could see the reflected image of this inside the plane mirror. This image is formed due to reflection, and as these parts are the reflected part, therefore it is equal, and therefore it is an example of reflectional symmetry. So now, what is rotational symmetry? Rotational symmetry is possessed by an object when it coincides with itself in a total rotation of 360 degrees. Before going to my model on rotational symmetry, let's understand some important terms. The important terms are the center of rotation. Here in my model, I've marked the center of rotation as a pin or a thumb pin, and this center of rotation is the central point of the figure about which axis the figure will be rotated. Then we have another important term, that is the angle of rotation. The angle of rotation is the angle where the figure will be coinciding with itself in a rotation of 360 degrees. And then the order of rotation. The order of rotation is the number of times the figure coincides with itself in a total rotation of 360 degrees. Now I'll be explaining you about my model. So first we'll be taking a piece of square, and here is a big black dot at 0 degree. Now we'll start rotating it. We see that at first it coincides at 90 degree, and another time when we rotate it, it coincides with itself in 180 degree. And in another rotation, it coincides with itself in 270 degrees. And for the rotation, it adapts in 360 degrees. Therefore, we conclude that the square has an angle of rotation of 90 degrees. That means in every 90 degrees, it will be coinciding with itself. And then the order of rotation is 4. That means it has 4 angles where it will be coinciding with itself. That is 90 degree, 180 degree, 270 degree, and 360 degree. Then I'll be showing you about a rectangle. So here I've taken a piece of rectangle and I will be start rotating it. We see that at first the rectangle is coinciding with itself in 180 degrees. And in another rotation, we see that the rectangle is coinciding in 360 degrees. Therefore, we conclude that the rotation of 180 degree. That means in every 180 degree, from 0 degree to 360 degree, it will be coinciding with itself. And in the order of rotation, it has 2. That means it has 2 angles where it will be coinciding with itself. Similarly, I've mentioned some more shapes that are circle, which has angle of rotation as every angle or any angle. And the order of rotation is many. Then I've taken an isosceles triangle, whereas angle of rotation is 360 degree and the order of rotation is 1. The parallelogram has an angle of rotation of 180 degree and the order of rotation is 2. An uneven-sided star, whose sides are all of uneven, has angle of rotation of 360 degrees and the order of rotation is 1. At last, I would like to tell you some important facts. They are: the order of rotation of any regular polygon is equal to its number of sides. For example, we take a regular polygon as the square. The number of sides in a square is 4.
And also, I've mentioned in the chart that the order of rotation of square is 4. So this fact is proved correct. Another fact is that about the angle of rotation, that the angle of rotation of any figure you take is the smallest angle where it coincides with itself. You have seen that I have tried with a square and with the rectangle. The square first coincided with itself in 90 degree and the rectangle at first in 180 degree. Similarly, in the angle of rotation in the chart, I had mentioned that the angle of rotation of a square was 90 degree and the angle of rotation of a rectangle was 180 degree. So this fact is also proved correct. At last, I'll be concluding my discussion with that symmetry not only helps us in making things easier around us, but also making things beautiful. With this, I would like to sign off. Thank you.
Thank you so much. We are impressed with your presentation. You are in class 7, right?
Yes, sir.
Okay. So what about this mirror image you said? Can you consider as a symmetric image?
Yes, sir. It's a symmetric image.
Suppose
It's a
I will
symmetry
stand.
of
Okay. Suppose I will stand before a mirror. My left hand will look like right hand. Right hand will look like left hand. So how can
Yes, sir.
suppose I have a pen in my pocket? It looks like it is in the other side.
So,
When you are standing before a mirror, you raise your left hand, but in the mirror you will see the right hand is raised. So how can you consider it as a symmetric picture? How it is symmetrical?
in such cases, it is not considered as a symmetrical picture because in that picture the lateral inversion will take place, so we cannot consider. But in some pictures, such as I've taken a symmetrical picture over here, which I've drawn, so that we can consider.
Okay. Okay, thank you. Thank you so much.
Welcome, sir.
Thank you, Priyansi.
Welcome, ma'am.
Coming to the next presentation, the project name is Theorems Based on Triangles, and it will be presented by Aditya Malik, Sakya Singh, Sthita, and Subhasis.
A very good afternoon to one and all present over here. Welcome to our project display. Myself Aditya Malik, and here are my teammates Sakya Singh, Subhashish Nanda, and Sthita Prakyan. Our topic is theorems based triangles. Hope you like it. So first let us know what is a theorem.
In mathematics, a theorem is a non-self-evident statement that has been proven to be true on the basis of previously established statements. As a result, the proof of a theorem is often interpreted as justification of the truth of the theorem statement. The theorems we are going to discuss in our project are based on triangles.
Before knowing about our theorems, first let us discuss some situations which can be solved by using our theorems.
Be louder.
Before going to the theorems, first let us discuss some situations which can be solved by our theorems. Problem 1. Suppose a man wants to fix a LED light on the front wall of his house to make his house look beautiful. He wants to fix the light in such a way that it should be exactly in the middle of his house, and it should also be parallel to the base of his house. What will be the length of the LED light if the length of the base of his house is 60 meters? This situation can be solved by the midpoint theorem. Now, before solving the problem, let's discuss the midpoint theorem. If the midpoints of two adjacent sides of a triangle are joined by a line segment, then this segment is parallel to the third side. This theorem is known as the midpoint theorem. Now let us know the midpoint theorem in detail. Here, as you can see, a triangle ABC, AD is equal to 15 centimeter and DB is also 15 centimeter, which proves that D is the midpoint of AB, and AE is equal to 15 centimeter and EC is also 15 centimeter, which proves that E is the midpoint of AC. DE is a line segment. Angle ADE is 55 degree and angle ABC is also 55 degree, which proves that DE is parallel to BC. Hence, it proves that the midpoint theorem does exist. Now, coming back to our problem, the man can use the midpoint theorem to fix the LED light exactly in the middle of his house, and it will also be parallel to the base of his house. If the base of his house is 16 meter, according to midpoint theorem, the LED light required by him will be 16 meter by 2, 8 meter. Now let us see some applications of the midpoint theorem. There are many applications of the midpoint theorem. The midpoint theorem is often used by architects for designing houses, bridges, buildings, etc. It is also used by artists while they are painting any landscapes. As we can see in the problem 1, the midpoint theorem can also be used in household works. Now let's move on to our problem 2. Let's suppose at a certain time of the day, a man 6 feet tall casts his shadow 8 feet long. Find the length of the shadow cast by a building 45 feet long high at the same time of the day. This problem can be solved by basic proportionality theorem. Before solving the problem, let's discuss about the basic proportionality theorem.
In a triangle, line drawn parallel to one side will divide the other two sides in the same ratio. This theorem is also known as the basic proportionality theorem. Now let's discuss about it in detail. First, let us see if DE is parallel to BC. As you can see, the measure of DE is 55 degree and the measure of angle B is also 55 degree. Hence, DE is parallel to BC. Now, AD, DB, AE and EC, all four are 15 meters in length. Hence, if we divide AE by EC is equal to 1 and also AD by DB is also 1. Hence, it is proved that the basic proportionality theorem exists. Now, moving on to our problem, as we have seen that XZ is parallel to PQ. Hence, the basic proportionality theorem can be used. So, if we 45 degree divided by 6 feet, that is height of the building divided by the height of the man is equal to shadow of the building divided by the shadow of the man. Hence, 45 by 6 is equal to A by 8, which proves that A is equal to 360 by 6 feet, 60 feet. Now, let us know about some applications of the basic proportionality theorem.
This theorem also has many applications. This theorem can be useful in case of painting, tiles, and many other things which require precision. This theorem helps us to make sure that the items are in proportion. Now let's move on to the third problem. A doctor advises John to walk 8 km daily to reduce the angle bisector of the field divides the side of length 4 km in the ratio 1:3. One side is 1 km long. How many rounds he should walk to complete a distance of 8 km? This problem can be solved by vertical angle bisector theorem. Before solving the problem, let's move on to the vertical angle bisector theorem.
Third theorem. The bisector of the vertical angle of a triangle divides the base in the ratio of the other two sides. This theorem is also known as the vertical angle bisector theorem. Now let us discuss this theorem in detail. Here you can see that BF equals to 15 centimeter and FC is also equals to 15 centimeter. AB equals to 30 centimeter and AC equals to 30 centimeter. Hence, AB by AC equals to BF by FC, which is equals to 1. Hence, prove that the vertical angle bisector theorem exists. Now, coming back to our problem, here the vertical angle bisector theorem can be applied. Here, BC equals to 4 km and BF by FC equals to 1/3. So, BF equals to 1 km and FC equals to 3 km. Now, AB by AC equals to BF by FC. So, AC equals to 3 km. The perimeter of the path is 8 km. So, John should walk only one round around the path to complete a distance of 8 km. Now, let us discuss some applications of this theorem.
The applications of vertical angle bisection theorem. This theorem is also used by architects. More and more of the constructs are done by machines. The programmer who write the programs for the machines who do the designs need to know how
You are
to
not
bisect.
audible.
And can I again tell?
Yes, yes. Repeat.
This theorem is also used by architects. More and more of the constructs are done by machines. The programmers who write the programs for the machines who do designs need to know how to bisect angles.
Thank you.
You have taken a triangle where ABC is the triangle and there is another side DE which is parallel to it. So can you please show the figure? There is a triangle ABC and inside there is a segment which is DE parallel to BC. Now let us take a situation where AD by DB is 1 by 2. AD is to DB is 1:2. Then what will be the ratio of areas of ADE with ABC?
Sir, can you tell the question again?
Take a triangle ABC. In AB, take a point D, and on AC, take a point E, such that DE parallel to BC. And AD is to DB is 1:2. Then what is the ratio of the areas of ADE to areas of ABC? You have the figure.
Sir, your voice was breaking. Sir, can you tell the question again?
Okay. DE are points on AB and AC respectively, such that DE parallel to BC. Is it clear?
Yes, sir.
Then ratio of AD to DB. AD is to DB is 1:2. Is it okay?
Yes, sir.
Now, what is the ratios of areas of ADE to ABC?
So as the triangles are similar, the ratio of the area will be 1:4.
So, what is the ratio of the corresponding sides?
1:2.
Did I say it?
As you said, 1:2.
No, I said AD is to DB. I didn't say AD is to AB. I said AD is to DB is 1:2. Your theorem is okay to apply, but thing is you need to know what is the ratio of the corresponding sides. You are bang on with the theorem, but you are not okay with the ratios. Okay, then no problem. So it is AD is to DB is 1:2. So AD is to AB will become 1:3. Is it clear?
Okay.
Then your
Yes,
your
sir.
ratio of areas will be 1:9. Thank you.
Thank you, dear students. Moving on to the next presentation, I would like to invite Abhilasa, Abhirup, and Adyasa to present area and perimeter of parallelogram and its application in daily life.
Thank you, ma'am. Good afternoon to one and all present over here. Respected
Excuse me,
teachers
ma'am.
and
Excuse me, ma'am. Ma'am, please make another Abhirup the co-host. And there are two Abhirups. So that I can unmute.
Okay, you start.
Good afternoon to one and all present over here, respected teachers and my dear friends. Welcome to our presentation, which is about area of a parallelogram and its applications in our daily life. I'm Abhilasha Panda and my teammates are Abhirup Tripathi and Adyasha Panda. We are the students of class 7C.
So friends, we are acquainted with all types of shapes and objects around us. One of them is about the parallelogram. A parallelogram. So one of them is of parallelogram. Now the question arises in our mind, what is a parallelogram? A parallelogram is a special type of quadrilateral in which the opposite sides are parallel. We also see a lot of parallelogram like shapes and objects around us.
So let us move to the applications of parallelograms in our daily life. Here I have the model of a house whose roof is of the shape of a parallelogram. So we can see such types of houses in both rural and urban areas. I have a field which is of the shape of a parallelogram. So now I want to fence this field with wire. How can I find the length of wire required for this purpose? I want to lay tiles on the roof of my house. How can I find the expenditure and the number of tiles required for this? To solve the above problems and to make sure that no shopkeeper cheats me, I need to find the area of the lawn and the perimeter of the roof of the house. So now let us know how to find the area and perimeter of any object that is of the shape of a parallelogram.
Now I will tell how to find the area and perimeter of a parallelogram. Now this is a parallelogram which is made up of three familiar figures, one rectangle and three congruent triangles. This is the height of the parallelogram and this is the base of the parallelogram. The formula for finding the area of the parallelogram is base into height. So one question arises in my mind. How can we prove that the formula for area of the parallelogram is base into height? So for this, we first need to convert this parallelogram into a rectangle. Now, this is a rectangle. The base and height of the parallelogram also get converted into breadth and length of the rectangle. The formula for finding the area of the rectangle is length into breadth. So, for the formula for finding the area of the parallelogram will also be base into height. So now, to find the perimeter of the parallelogram, we need to add all the sides of the parallelogram. Now I think you must have got some idea how to find the area and perimeter of a parallelogram. With a little hope, now I want to sign off. Thank you for your present hearing.
Thank you, Avilasa. Is it, can you apply this for your rhombus?
So can you repeat the question?
Question is, can you, what you have used, can you use this concept to rhombus?
Yes, sir. Sir, the area of a rhombus equals to the base into the altitude. Sir, so we can use it for a rhombus also.
Okay. Can I say that every rhombus is a parallelogram?
Yes, sir. Sir,
because
sir, because its opposite sides are parallel to each other.
Okay. Do you agree that what are they are called? diagonals. The diagonals of a parallelogram bisect each other. Is it okay?
Yes, sir.
Yes?
Yes, sir.
Okay.
Thank you, dear students. Our next presentation is transversal and parallel lines to be presented by Shriya Sital Sahu and Himanshu Sekhar.
Look at the pictures shown in this slide. What are these pictures about? Can you mark any similarity among all these pictures? Yes, I can mark only one similarity among all the pictures shown in this slide. That is, 2 to 3 lines are intersected by a single line by different points. So you will find these applications in various other objects also, such as a chessboard where many lines are intersected by a single line at different points. We will also find this application in a badminton racket where the net comprises of many parallel lines which are intersected by a transversal.
Yes, Shreya, you have given a hint to our online viewers what we will explain today. So let's start. Respected jury members and my dear friends, I am a favorite Himanshu Shekhar Sahu and this is my partner Shriya Sahu. We two are here to explain about a project that's parallel lines and transversal. So let's start without any break.
So, by hearing our project's name, there must be a question arising in your mind. That is, what is a transversal? The line which cuts 2 or more lines at different points is called a transversal. The aim of our project is to show all the properties of 8 angles found by a transversal when it cuts 2 parallel lines. Through our project, people will be able to have a clear idea about a pair of angles such as corresponding angles, alternate interior angles, alternate exterior angles, and co-interior angles.
As you can see in our model that the black line, this below 2 black lines is a pair of parallel lines and this pink line is a transversal. When parallel line L and M is cut by the transversal line N, then 8 angles are formed. Also, the correspondence, the 2 pairs of corresponding angles, the 2 pairs of alternate exterior angle and the 2 pairs of alternate interior angles are same and the co-interior angles equals to the sum of 180 degree. Here you can see that I have written all the angles which is equal to the corresponding angle or interior angle or exterior angle. So let's know about the essence of these angles.
Yes, now comes the question of the type of angles which are formed by when 2 parallel lines intersect by a transversal. So the first pair of angles are corresponding angle. The pair of angles which are on the same side of the transversal in the matching corners of the parallel lines are known as corresponding angles. They have the equal measure.
So we will show here our corresponding angles are equal. So I have taken one of the angle pair that's 1 and 5 from the corresponding angles. So here is a protector and let's measure angle 1. Here angle 1 comes 100 degree. So I have taken a solo piece of 100 degree and put it here. As you can show that angle 1 measures 100 degree. And here I will take it to angle 5. And here it comes that the same. So we can proudly say that angle 1 and 5 are equal as per a corresponding angle property. So we can say that 2 and 6 are also equal, 3 and 7 are also equal, and 4 and 8 are also equal.
Next comes the pair of alternate interior angles and alternate exterior angles. The pair of angles that lies on the inner side of the parallel lines and are opposite to each other are known as alternate interior angles, and the pair of angles which lie on the outer side of the 2 parallel lines and are opposite to each other are known as alternate exterior angles. Both these pair of angles have equal measure.
As you can still see, listen that the alternate angle, which is exterior, is always found at the exterior or the outside of these parallel lines, and the interior, the alternate interior angle will be found inside the parallel lines. So let's take one of the exterior angle, and I have taken here 1 and 7. So here 1 equals to 100 degree, and now let's measure, is 7 also 100 degree? So here you can see that angle 1 and 7 is 100 degree. So alternate exterior angles are equal. In the same way, 2 and 8 are also equal. Then now next goes to alternate interior. Alternate interior angles found inside. So it must be 4 and 6 and 3 and 5 as they're opposite to each other. So I have taken angle 3 and 5 for the model. Here angle 3 equals to 100 and angle 5 equals to 100. So thus we can say that angle interior alternate exterior angle and alternate interior angles measures equal.
Next comes the last pair of angles which are formed through it, that is the co-interior angles. The pair of angles that lies on the inner side of the two parallel lines and on the same side of the transversal are known as co-interior angles. These angles combine to form a supplementary angle or 180-degree angle.
As from the wording, co-interior angles, we can understand that these interior angles must be inside of these parallel lines and should be matched with the transversal. So here, the interior angles are 4, 3 and 5 and 6. So here 4 and 5 are touched with the transversal and 3 and 6 are also touched with the transversal. So these two are the co-interior angles. So let's prove it. Here angle 4 will be 80 degrees. So I have taken an 80-degree symbol. So here you can see that angle 4 equals to 80 degree. And as you can see that angle 5 is equals to 100 degree. So 100 plus 80 degree equals to 180 degree. So as you can see that the co-interior angles is 180 degree. The same way 3 and 6 will be also 180 degree. So here co-interior angles forms to be 180 degree.
So our activity helps us to get a clear idea about the parallel lines, transversal and the pair of angles that are formed through it. This will help us to solve some geometrical questions. So hope it helps you to understand the concept. Thank you.
Okay, I'm making a statement. Please see the validity of it. Whether it is true or false, you have to say. A pair of corresponding angles are equal.
Yes. A pair of
Sir, please repeat the question.
You have to tell whether it is true or false.
Yeah.
My statement is a pair of corresponding angles are equal.
Yes, sir. True.
Yes, sir.
A pair of
Yes, sir,
corresponding. True.
It is true?
Yes, sir. It's
Yes,
true.
sir.
It's true.
Sir, when two parallel lines are intersected by a transversal, then only the pair of corresponding angles are equal.
But you said true, but I didn't say whether they are having parallel lines or not. I am making a statement here. A pair of corresponding angles are equal.
Sir, no, sir, false.
Yes, it is
Sir,
false.
actual false.
Yes. Okay. Now, what is linear pair?
Sir,
So linear pair means so 180 degrees. So when the two angles are mixed, sir, it's equals to 180 degree.
Okay, so I have this side one angle whose measure is 120 degree, and to this side another angle whose measure is 60 degree. So they are linear pair, right?
No, sir, they must be in one line. Like here you can see in our model, 5 and 6 are there. If one will be 120, then another will be 60. If this will be 120 and this one will be 60, then it can be called as a linear pair. So if there will be in equal sides, then we can say that it's the 180 degree
So
or a
can you
linear
specify
pair.
now? So you said
So
sum is 180. Again, you contradict your statement. Now please tell me what is linear pair.
So according to sir, the one pair means they equals to sum equals to 80 degree means 180 degree, and they are found equal means in one line they should be intersect.
So what
Means
are
they will be there.
these angles?
So linear pair. So 5 and 6 can be a linear pair here.
Okay, okay then it's okay. So actually they are adjacent angle. They must be adjacent. And what you told is correct,
Yes,
that
sir, they
they
must
must on a straight line. But again, I can contradict your statement. I can have a straight line. I can have an angle here as 60 degree, and I can have another angle as 120 degree. They are not linear pair. They must be adjacent. That is the fact.
Yes, sir, they must be adjusted.
Clear?
Yeah. Yes, sir.
Thank you. Thank you so much.
Welcome, sir.
Thank you, dear students. Moving on to the next project to be presented by Jibitesh Jena, Rashmi, Abhinav, and Padmini. And the name of the project is Verification of Pythagoras Theorem.
Thank you, ma'am. Big as an opportunity. So today we are present here to present our topic for the annual exhibition of mathematics. It's the verification of Pythagoras theorem. It is being presented by Jivitesh Jena and Rashmi Chandan Mishra of class 6B, Abhinav Mahanti and Padmini Priyadarshini of class 6A. So let's start. In our day-to-day life, we face many problems. Some of them are depicted here. In this picture, we can see that a painter is painting a wall and he is using a ladder for this purpose. And he is using a ladder for this purpose.
Jibitesh,
Yes, ma'am.
on your video.
Yes, ma'am. Ma'am, can you see?
Yes.
In this picture, a painter is painting a wall and he is using a ladder for this purpose. But he needs an accurate measurement of the ladder so that he can paint the wall of the house without facing any problem. In the above situation, a building has caught fire and the fire brigade has come to put out the fire and to rescue the people. The firemen saw that the base is of 30 feet and the height of the building is 40 feet. So how long should be the length of the ladder? So, do we have any solution to these problems? The answer is yes, sure. We can solve these problems after we understand the concept of Pythagoras theorem.
Here, a question arises in our mind that how will we do so? Yes, we will do so by Pythagoras theorem. So, what is Pythagoras theorem? The theorem of Pythagoras is an equation connecting the longest side of the right-angled triangle called the hypotenuse with the other two sides, that is, base and height. The great mathematician of Greece, Pythagoras, said as well as proved that the length of hypotenuse square is equal to base square plus height square. So, hypotenuse is equal to root over of base square plus height square. Pythagoras theorem can be used to find the length of one side of the right angle triangle given the other two sides. It applies only to right angle triangles.
Rashmi, please continue.
Here in my video, you can see that this is the base, this is the height, and this is the hypotenuse. So in my project, I can prove the Pythagoras theorem. Here we have to know that a square plus b square is equal to c square, which is applied here. 3 square plus 4 square is equal to 5 square, means 3 square is equal to 9, 4 square is equal to 16, 5 square is equal to 25. 9 plus 16 is equal to 25. In my project, you can also see that the base is 4 centimeters, the height is 3 centimeters, and the hypotenuse is 5 centimeters. I can also give you another example. Let's take 5 square plus 12 square is equal to 13 square.
अपनी होस्ट
Here you can see that. Here you can see that the base is. Here you can see that the base is 12 centimeter. The height is 5 centimeter. So the hypotenuse is 5 centimeter. 5 square plus 12 square is equal to 13 square, which is equal to 25 plus 144 is equal to 169. Also, hypotenuse is equal to root over of 12 square plus 5 square, which is equal to root over of 144 plus 25, which is equal to root over of 169, which is equal to 13. Which you can also see in my project that the base is 12 centimeter, the height is 5 centimeter, so the hypotenuse is 13 centimeter.
So now we understood the usage of Pythagoras theorem, and by using this property we can find the solutions to these problems. Here, the height was of 4 meter and the base was of 3 meter. So the hypotenuse will be root over of 4 square plus 3 square, which is equal to root over 16 plus 9, which is equal to root over of 25, and which we get as 5. So the length of the ladder is 5 meter. Here the length of the ladder, which is equal to the hypotenuse of the triangle formed, is equal to root over of 40 square plus 30 square. 40 square is equal to 1600 and 30 square is equal to 900. So root over of 1600 plus 900 is equal to root over 2500, and we get as 50. So the length of the ladder used by the fire brigade is 50 feet.
Abhinav.
So now I'm going to prove that how a square plus b square is equal to c square. So in this project, it contains one of the triangle and 3 squares. The measurement of the squares is measure A, measure B, and measure C. So I've taken some blocks in A square and B square. So the area of the side A is A square and the area of the side B is B square. And the area of the side C is C square. So I'm taking out the blocks from C square to prove that A square plus B square is equal to C square. So I'm arranging the blocks from A square and B square in the C square block. So hence the box is filled up with the blocks of A square and B square. So hence it's proved that A square plus B square is equal to C square. Thank you.
With this, we all the members sign
Okay, so this is a good presentation. The last one is very impressive. So can you tell me, suppose I have a rectangle. I want to use Pythagoras theorem there. In what way it will help me? What I can find out of a rectangle taking the help of
So you can find the size of the rectangle.
Yes.
Sir, for example, we can take an LCD TV, or sir, also the monitor.
So what we will
Monitor
find
of a computer. So you can find the size of the objects.
Yes,
sir. Size
Sir,
means?
it is the diagonal of that objects. So the diagonal of the shapes.
Okay. So in what way practically it will help me?
Sir, for example, you have gone to buy a TV. So you need to buy a TV of 32 inch or 25 inch. So the diagonal of the TV should be of 32 inch or 25 inch, so that you will buy it. And the diagonal is the line which connects two opposite corners in an object.
Okay. Okay, thank you.
You have taken the sides of a triangle, right triangle, that is 3, 4, 5 or 30, 40, 50. What do you call these 3 numbers, 3, 4, 5? Is there any specific term for this 3, 4, 5?
So the Pythagorean triplet.
Yes?
Sir,
Pythagoras triplets.
Okay, Pythagorean triplets.
Yes, sir.
Is it 9, 40 and 41? Are they triplet? Pythagorean triplet?
Sir, 9.
9, 40, and 41. Nine, 40, 41.
Sir, can you please repeat?
Yeah. 9 square is 81. 40 square is 1600. Now it's your turn to calculate 41 square.
Yes, sir.
So
9 into 9 is equal
1681.
to 81. 40 into 40 is equal to 160. So answer will be 1681. And 41 into 41 is equal to 1681.
Yes,
So
sir.
what is 40 square?
Sir, 40 square is
40 square
1600.
is equal to 1600. And 9 square is equal to 81.
81.
Thank you so much.
Yes, sir.
Thank you, dear students. Coming to the next
Welcome, ma'am.
project, why angles are necessary in daily life? I would like to invite Shraddha Mishra, Kavya Krishna, Arjun, and Aishani for the presentation.
Yes. Good evening, esteemed teachers, respected jury members, and my dear friends. Myself, Shraddha Mishra, student of grade 6, section E. Now, can you all see this swing over here and this windmill? Do you find any similarities between them? Yes. Both of them have angles. Angle is present everywhere in this world. Even our Earth is tilted to an angle with the orbit, because of which seasons and day and night is caused. Our bones also have angles between them, which enables us to move. With this, you would have guessed our topic. It is, why are angles necessary in daily life? So, our team members are Arjun Mishra, Krishna Mishra, and Aishani Satpathy. Before telling you about angle, I'll tell you what is geometry. Geometry is the study of sizes, shapes, positions, angles, and dimensions of things. Angle. Angle is a shape formed by two rays or arms by meeting at a common point, which is also known as the vertex. The standard unit of angle is degree. Now, I'll give you some real life examples. The legs of this swing form an angle so that they can hold the iron bar at the top. The blades of the windmill form an angle between them so that they can move and produce electricity. Then, the legs of the table also form angles so that they can hold the top part of the table. For the last one, we have the chair. Also, the legs of the chair form angle to provide support to the upper part. Also, there is an angle formed between the backrest and the seat, which enables a person to sit on it comfortably. Now, Kavya and Aishani will tell you about types of angles.
There are mainly 7 types of angles. They are, firstly, zero angle. An angle which measures 0 degree is known as zero angle. An angle which measures between 0 degree and 90 degree is known as acute angle. An angle which measures 90 degree is known as right angle. An angle which measures between 90 degree and 180 degree is known as obtuse angle. An angle which measures 180 degree is known as straight angle. An angle which measures between 180 degree and 360 degree is known as reflex angle. Lastly comes the complete angle. An angle which measures completely 360 degree is known as complete angle. Now we have completed the types of angles. Now a question will arise in everyone's mind that why and how we use these types of angles in our day-to-day life. There is an answer. Engineers and architects use angles to design buildings, roads, and other sporting facilities, while the carpenters use angles to make chairs, tables, and sofas. We also find many types of angles by Portugal clock. For example, this for right angle, this for acute angle, this for obtuse angle, this for straight angle, and lastly, this for reflex angle. So now, I want to call my friend Arjun to show us a beautiful project on why are angles necessary in our day-to-day life.
Thank you. Good evening to all the respected panel members. Now I am going to show you my model for the math topic angles. Why are angles needed in our real life? So let us start without any delay. So in my model, I have shown four sections.
Arjun, you are not audible.
I'm now audible.
Take your earphone, please. Take out your earphone.
Yes, ma'am, taken out.
Okay. Arjun, now also you are not audible.
Ma'am, I have, ma'am.
Mute করছো?
No. Ma'am, now audible?
Yes, yes. Arjun, continue.
Now in this section, you can see three children are playing football in a circular field. The angle between the students marked by the yellow structure is an example of acute angle.
Arjun, not audible here.
In this section, you can see three children are playing football in a circular field. The angle between the students, which is marked by the yellow-like structure, is an example of acute angle.
Arjun, please see that you are audible. Your voice is not at all audible. Now you only tell. You whatever explanation you want to do, you just do it. Already your project, already it is seen by judges and all of us. Kindly explain whatever you would like to tell, please.
Importance of angles. So now we can understand the importance of angles in our real life. Angles are needed in everything, for the construction of houses, for the construction of link roads, and for the construction of benches, we need to know angles. And angles is very much required for the construction of dams. Thank you for your patient hearing.
Thank you, Arjun.
Thank you. Thank you so much, children. You have done very beautiful projects. You are in class 6 or 7?
Class 6. Class 6.
Okay. Can you just give a real life example of an angle? Means you just have to justify how the angle is important as far as the degree of precision is concerned, means the error margin is concerned. Suppose I want to make some project where one angle is required, and there the angle should be exactly same as required. If there is an error, and that error is not tolerable.
Sir, can I say?
Yeah, please.
Sir, angles Howrah Bridge. In the Howrah Bridge, we need an exact measure of angles because in the Howrah Bridge there are many rods, and the rods are arranged in such a way that the angle between them is an value of exact measure. Sir, I don't know the exact measure, but I know that it should be an exact measure.
Okay. At the same time, can you give an example that where angle little bit of error is tolerable?
Sir, no, sir. Sir,
you gave an example of a farmer. Farmer is making a bullock cart. There is using two wheels. In between there are scopes. They are made of wood. Have you seen a bullock cart?
Yes, sir, seen. Sir, they are used for the farming.
Yeah. So when those scopes, the angle between any two neighboring scopes, adjacent scopes, may not be exactly same. There can be some error. But the same wing, when you use for an aeroplane, the engineers cannot make mistakes. The angle between the wings, the scopes should be measured as per the engineering calculations. Isn't that it?
Yes, sir. Sir, also in the bench, some error value of angle is also tolerable.
Right. Good. Okay.
Thank you, sir.
One question. You are using a clock while discussing about angle. Let us say the time is 6 o'clock. The time is 6 o'clock, 6 p.m. So what is the angle?
The straight angle.
The straight angle.
What is the measure of it?
Sir, 180 degree.
180 degree.
180 degree. Now, when you will have 90 degree exactly? At what time?
The clock strikes 9 o'clock.
Sorry?
The clock strikes
3 o'clock or 9 o'clock, both.
3 o'clock.
3 o'clock and 9
9
o'clock.
o'clock.
Okay.
Yes, sir. Sir, but if 9 o'clock back, then it will be reflex angle.
The opposite will be reflex angle. Okay. Now, what is the angle at 1 a.m. or 1 p.m.?
Sir, it is 30 degrees, sir, because because the angle between the hour and the minute is 30 degrees.
Okay. Now, let us talk of second hand. In your clock, there was no second hand. Let us take second hand concept. Now, if in 1 minute, how much angle you will get when second hand will rotate for 1 minute?
In 1 minute?
Yes, 1 minute.
Sir, I am 360 degree.
Sir, complete angle 360 degree.
Yes, very good. Very good. Thank you.
Thank you, sir.
Thank you so much, children, for your nice presentation. Last but not the least, the last project of the day is going to be presented by Mehek and Akshada, and the name of their project is Little World of Circles.
Thank you, ma'am, for this opportunity.
Good evening, one and all present over here. Myself, Akshada Mishra from 6D.
Myself, Mehak Das from 6A.
Today, we both are going to explain our project on the topic Little World of Circles. What is a circle? A circle is a round-shaped flat surface. It neither has vertices nor edges. Some examples of circles and circular regions are coins, bangles, CDs, playgrounds, clocks, pizzas, etc. There are many importance of circles in our daily life. For example, the wheels of all the vehicles are circular in shape. This helps in the rolling of wheels, which thus helps in the movement of vehicle. Now, during the recess, the students of class 6 went to the playground. While playing there, they explored some important points about circles. Now, let us see what they found. Here, two girls are standing in the circle at the end points in opposite directions. And now, we have to find out the distance between them. So, in this case, we need to know about diameter. What is a diameter? Diameter of a circle is any straight line segment that passes through the center and connects two endpoints on the circle. So here, if we know the measurement of the diameter, we could easily calculate the distance between them.
So let's see an activity now. Here you can see a thread is connected to the center of the circle and the boundary of the circle, and the length of the thread is equal everywhere. So what is this thread known as? Yes, you are right. It is the radius of the circle. A radius of the circle is a line segment which connects the center of the circle to the boundary of the circle. For example, here some boys are inside a circle and they want to stand equal distance with respect to the center. So here they have to calculate the length of the radius. If they calculate the length of the radius, they can easily stand equal distance with respect to the center.
Now, during the recess, a girl went to canteen to have a pizza. While eating a piece of pizza, she wanted to calculate the perimeter of it. So here, we'll have to calculate the perimeter of that sector of the pizza. So to calculate the perimeter of the sector, we need of the arc and the length of two radii that surrounds the pizza.
So here you can see some boys and girls are inside a rectangular field. The girls are inside the circular playground and the boys are inside the basketball court. So here the girls are inside the playground, so they are the interior of it, and the boys are standing outside of the playground, so they are the exterior of it.
While playing, the students observed their running track. They found that their playground is big, so 200-meter race could be organized easily. But they thought that in the schools having small playground, can 200-meter race be organized? So our answer will be yes. It can be organized by making little path straight and little path curved. For example, here we have an example of track for small playground. Here we can assume the straight path to be 40 meter and the curved path to be 60 meter. We can also take the straight path 60 meter and the curved path 40 meter. If the length of the path is much greater than the breadth, we can take the straight path as 70 meter and the curved path as 30 meter. By this method, even the schools which have small playground can organize running races of 200 meters or 400 meters. Now, the school bell rang, so the students went to their classes. Thank you for your patient hearing. Now we are open up for any questions asked by you.
Thank you so much, children. Akshada. Is it audible?
Yes, sir.
What do you mean by a chord? Chord of a circle.
Sir, a chord means any line segment that connects any 2 points on the boundary of a circle.
Okay, good. What is the largest chord of a circle?
Sir, it is the diameter.
Okay, what is a secant?
Sir, can you please repeat?
What is a secant? Do you know what is a tangent?
No, sir.
Okay, no problem. You are talking of sector, right? Whether you have gone through areas and how to find the length.
Sir, can you repeat?
I mean to say that whether you have gone through how to find the area of a sector, because you are 6, but whether you have gone through it, because you are doing such a nice project. Okay, I think no problem. So if you take one piece of a pizza, you will get a sector. Can you name that and can you tell the remaining part? Let's say a pizza is cut into let's say 12 pieces, 12 equal pieces, and you have removed only one piece, and that means you are getting two part. Okay, so can you please name them, because you have used the term sector.
Sir, the one piece will be minor sector and the rest one will be major sector.
Okay, very good. Thank you so much.
Okay, thank you.
Thank you, sir.
Thank you, dear students. Now we have come to the end of the program. Thank you all the participants and all the viewers present in the program. Thank you one and all.